So what they've essentially done is that Hezbollah they were convinced a few months back to do a fresh batch of purchases for these devices. Somebody convinced them basically, and so they ordered these new pages, and they come from Asia and I believe Taiwan. We're going
So this is what one of the theories I had last night, I think, is that they would warm up the batteries remotely.
to talk about the details of that as well. And
They
obviously,
were, I said they must have short circuited the batteries to cause them to explode. A battery has a lot of energy. We've seen batteries explode. We know, batteries can explode.
the Mossad side already managed to get to them beforehand. So the explosive material was inserted before the devices reached
So they short circuited the batteries and had explosives in the device.
Hezbollah. Their supply chain was actually infiltrated. Al Jazeera adds further details that 20 grams of explosives were placed in each device, and Hezbollah began using them 5 months ago. So it was interesting that they ensured that the delivery has taken place. Everybody has it, and they also came out to say Hezbollah came out to say the new devices they were being phased in, and initially they gave them to senior figures. So a lot of the individuals, including the Iranian ambassador to Lebanon, that's the problem, by the way, because he also had it and his bodyguards. Now we know that Hezbollah was created by the Islamic Republic of Iran. We know that they are allies anyway, but diplomatically speaking, it's not a good look for an official diplomat, an ambassador of a country, to also carry these devices, which is for
This is a violation of international law. I mean, in such a case, if a civilian is behaving as a militant, the military, I mean, he could get court-martialed and executed, and that is legitimate according to Geneva Convention. A civilian is not allowed to attack a warrior. If a civilian acts in any way against a warrior, a soldier, then that civilian can be executed according to the Geneva Convention.
directly for communicating with the terrorist organization.
Okay. I mean,
So
I could listen to this for a long time. This is very interesting. But as I said yesterday, this is really not necessary. I mean, it's okay to kill your enemy in case of an emergency, in case of a ticking time bomb. But in the long run, there is a better way. You can just make everyone wealthy, and wealthy people are calm, and poor people are frustrated and therefore violent. Violence is just a strategy to deal with poverty. So the Middle East is just very poor, and that's why it's very violent. That's all. The violence is correlated with poverty. So if you just get rid of poverty, you're getting rid of violence. Unfortunately, this war is making everyone poor. It's driving investment away from the region. It's making Israel poor. It's making Lebanon poor, Gaza poor. Everybody in the region is just becoming poorer, therefore more violent. Unfortunately. Now, the way to get rid of poverty is freedom, is economic freedom, which is not the current trend anywhere in the world, as far as I know. Except for Argentina, maybe the world right now is on course to less economic freedom, therefore more violence. Unfortunately,
now,
yeah.
now The latest information is also that the products, as we said, they did apparently come from Taiwan because of the paperwork. Now, New York Times have been doing some investigation about this. According to American and other officials briefed on the operation, these new batteries were made in Taiwan, but the companies in Taiwan are denying the allegations, saying, "Well, we didn't know what was happening." So, I mean, obviously, they're not going to admit because that's a bad look, and that's just going to give more excuse to.
No one knew about this. This is you don't want anyone to know anything. Anyone who knows anything becomes a weak link, whether they know it or not. You don't need someone to volunteer information. People by mistake volunteer information and people betray. And no one knew about this. No one anywhere in the world knew about this except for a handful of people who were involved in the project. Probably the people who were actually involved didn't even themselves know the details. They didn't know what they're doing, what it's for. Like you want separation of responsibilities and you want to hide as much information. So very few people knew about this concept.
Xi Jinping and the Chinese communists to take action. So they're never going to actually confirm this. Now, Hezbollah fighters, this is how it actually happened. The fighters, the current martyrs to be, received a message at 3:30 p.m. Lebanon time that looked like it was coming from Hezbollah's leadership. When the message came through, there was a brief pause.
So notice that Israel, now we know they know everything. I mean, the fact that they were able to plant these devices with the Hezbollah leadership means they were listening, and they probably still are listening to everything going on in Hezbollah leadership and everywhere else, probably in Tehran, in Lebanon, in Damascus. So Israel knows everything that's going on. I mean, Israel could have easily avoided October 7th. Unfortunately, Israel, as far as I know, created October 7th by funding Hamas through Qatar. And only God knows why they did it. I mean, this is just a government failure. There's no reason. These things don't have reasons. I mean, this is just government. This is exactly how they got Trump almost assassinated again 2 days ago after the first, as if the first assassination was not enough. I mean, these guys are useless. So, but when they want to get something done, yeah, I mean, they get things done. So, congratulations. All right.
Presumably so that the fighters would raise the pagers forward to their face before it actually goes off. So it gave enough time for them to check, and eventually, obviously, not every single person had the device on them. As we saw some of the videos, some of the Islamists, for example, it was in the middle of the afternoon, but they were taking a nap somehow, and some of the devices were on the bedside table or somewhere else. Someone was in the car, they forgot to bring it in. It was completely messed up anyway. So if it was actually Hassan Nasrallah sending a message to them, they would be in a massive trouble because they were all sleeping. But the others obviously did check their phones, their pages, and that's what happened to them. Now, open source Intel also gives us some more information about the company. According to the Hungarian company registry, it turns out that the Hungarian company BAC.
So the reason why Israel had to set it off was because it was becoming exposed. Like one guy in Hezbollah figured it out, and I think they assassinated him. They took him out, and they saw that the information was getting out, so they decided to activate the system. But I don't think this was by design, because there's no follow-up. It's not like Israel is attacking Hezbollah now. They could, as Yaron Brook said, this is a very opportune time, whether by design or not. But he predicted Israel will do nothing as a follow-up, and that's what we see. Israel is not doing anything.
think KFD.
So it was basically use it or lose it, and they decided to use it. Why not?
Which manufactured the beepers for Hezbollah, was only established in 2022 and reached a turnover of 1 million euros in just 2 years. Now, of course, then the link to the factories in Taiwan came. This is where obviously Taiwan has been denying the allegations. The domain was purchased in 2020, 2 years before the company was founded. The domain previously belonged to another company. The company's website is filled with generic photos. It claims to specialize in various consulting fields, including environment development and international relations. It is unclear with whom the company has worked or what it experienced.
Theoretically, it's a normal company that was funded. It could have been a normal company as far as the CEO is concerned and most of the workers. But they were told one day by the owners, we're going to work with this company. They're going to actually do some part of the delivery. No one paid attention, and that's when they made the modifications. But as far as anything else is concerned, it's just a normal company that's funded by some wealthy person or something. Happens all the time.
But the actual expense in. So we do know that is the actual website. The address is a private residence now in Budapest. The owner of the company, and apparently its only employee, has an impressive and maintained LinkedIn profile. However, it is filled with posts that are relevant to work and not typical for LinkedIn. She holds a PhD and she has no Facebook or Instagram account. There are only 3 or 4 pictures of her on the internet, which is very unusual. And the other employees listed in the company have strange names, fake profiles, or the actual people who do not work for the company. So this was the website that Hezbollah got in touch with to do the dirty work, essentially. Now, obviously, the company was fake. The profile picture for the person in charge was created in 2019. Her picture is also used often by other companies and other companies, suggesting it may be a fake picture. The other company also appears fake, and its phone number is disconnected. The company's website.
So with minimal due diligence, they would have figured out that it's a fake company.
It was blocked this morning, now requiring.
This shows you how unprofessional they are.
A username and password to access. Oopsie. It's a funny situation because obviously Hezbollah tried their best to keep things very in-house and double check everything and make sure all their sources are on their side. And they thought if they approach dodgy people, then that means it's a good sign. But obviously Mossad will infiltrate all the dodgy sources. Do not mess with Mossad. I can't believe it goes back to what the.
Yeah, it's the Mossad who created Hamas. So it's the Mossad is filled with super dummy dum-dums, but also geniuses, like basically everything else.
Going on for the past few months because while the Islamic Republic of Iran and Hezbollah of Lebanon both have been.
I mean, the Mossad, head of the Mossad, went multiple times to Qatar to pick up suitcases of cash and hand deliver them to the leaders of the Hamas in Gaza. That's the Mossad. So the Mossad creates its own enemies. It's government. Government. What else can I tell you? It's government. That's it. Beginning, middle, end. Government.
Not just threatening Israel, but Hezbollah have been hitting.
These are the same people that got Donald Trump and themselves almost killed already twice in a month. I mean, these are dummy dum-dums to the power of dummy dum-dums. But also geniuses. It's both.
Israel regularly. A number of children, obviously, in Israel also lost their lives a couple of months back. And everybody was waiting, saying, what?
Instead of an operation like this, they could have created an operation to make Gazans twice as wealthy, 10 times as wealthy. It doesn't take almost anything to make people super duper wealthy. Just let them do whatever they want. Just give them freedom. You need a government that will protect individual rights, property rights, and then people start building like crazy. They build skyscrapers and factories and technology. That's all you need. Just give them freedom. But no, they're gonna give money to Hamas to force the people of Gaza to become terrorists. That's what the Mossad is going to do. That's the genius of the Mossad.
What's Israel doing? They're very quiet. Why they're not hitting back? Why they're not doing it? Everybody was talking about a potential invasion by Israel. And it was like, well, there must be something going on. And then there was a lot of pressure on Netanyahu they still kept quiet. The cabinet kept quiet, everybody kept quiet, and then, whoops. Basically, Mossad catfished Hezbollah. They got catfished by Mossad. All right, super chat time. Is the Sun planning a full page 3 spread? On what? Naked Hezbollah people? Mike says, hey, it's my 75th birthday on Friday. I know I don't want to mature the page. Well, it's still 2 days to go, Mike. Calm down. But happy birthday in advance, Mike, one of our regular viewers, in case I forget on Friday. Just remind me. Anyway, what's going on with you guys in the...
What else we got? What's this? Woman, this is from a year ago, cries, why me after killing bride on wedding night? So the bride is the woman's. I don't get it. Frame dragging, artificial gravity. Okay, that's interesting. Exploding pagers.
Exploding pagers. Heard of that? Well, I guess you did, otherwise you wouldn't click this video. So what I'm going to do here is to give a brief analysis of what we know so far and maybe some more advanced stuff about it. So a quick recap of what happened, or at least what we know so far about what happened. Hezbollah, which is a terrorist organization stationed in Lebanon, at least it's designated as a terrorist organization by many of the Western countries. Basically, they use pagers to communicate. Why pagers? Because you don't want to use smartphones or really anything that can be tracked. So you go low tech so that you can avoid detection or espionage by the high tech. But yesterday at around 3 p.m. Lebanon time, all the pagers kind of went on at the same time and then exploded. We're talking about probably something like 5,000 pagers exploding, and well, each pager belongs to some Hezbollah member or activist or someone who's involved with Hezbollah. For example, the Iranian ambassador to Lebanon also got injured by an exploding pager, which kind of makes sense because Iran obviously funds and directs Hezbollah's behavior. Hezbollah is an Iranian proxy, so that's that sort of thing. Now, pagers are usually kept around one's crotch, and as you can imagine, having a pager explode near your crotch is, well, you can figure it out for yourself. The explosions don't seem to be very lethal from what we've been able to see and gather on videos that have emerged from the incident. Not that many people died, for, I think, as of now, about 10 people died, and we're talking about thousands of explosives going off, but we do have thousands of injured. So I guess the explosive was rather small, and it was probably designed more to sow confusion and, well, fear, probably.
Yeah, a lot of excitement, Brady, a lot of excitement. Because particle physics is still in the game, it hasn't died. It's amazing, isn't it? It's a bit like waiting for buses. I was thinking about this the other day. You're waiting for a bus, and then all of a sudden 3 come along at once. Yeah, we were all worried there was no new particle physics to be found. There was no new particles. We'd found everything that was going to be found. Well, we're waiting for a new particle, and then all of a sudden the BBC announces at least 2. There are sort of tantalizing hints of some really exciting new physics from 2 experiments, recent sort of announcements from 2 experiments. One of them is at CERN. It's the LHC-B experiment, and you might recall we've been to the LHC, and we saw the ATLAS detector, and we saw the CMS detector. So they're called general purpose detectors, these huge, fantastic pieces of kit which discover the Higgs. There are 2 more key detectors.
They never explain how these things work. What is a detector?
On the LHC ring.
They always show the same pictures, the same videos. We're so tired of it. Could you, for once, explain what is a detector, please?
One is called ALICE, but there's another one, LHC-B.
How many more times are we going to see this animation?
So the real excitement is coming from the experiment from Fermilab, where they've been looking at the magnetic moment of the muon. LHC-B is a high-precision detector that's looking for very fine events that might not occur very often, but by searching particular types of decay, then they've got a way of testing the standard model of particle physics very accurately. And it's through there that this potential new discovery has emerged. What they did was, if you remember, at the LHC, they fire protons around in opposite directions, and then they collide them. And they collide them here in the LHC-B detector. They're looking for the decay of a particular type of meson. A meson is a combination of 2 quarks, a quark and an antiquark. And they're looking for a meson called a B meson, which has got a B quark in it. We've got these 3 generations.
What's a meson?
Of quarks, and the B meson, also called the bottom or beauty, is the B quark is often associated with the top quark. You and I are made up of the up and down quarks. In fact, everywhere around us here, everything around here is made up of up and down quarks. So these B quarks are very rare, and they decay rapidly. They form in these.
Okay, there's no explanation, just the same jargon.
17, yeah, it's been around for a while, I think, if it's around at all. I'd read about it, I think a couple of, 2016 was the first time I came across it. This work done by these nuclear physicists in Hungary. They were looking at beryllium, the nucleus of beryllium. It's got 4 protons and 4 neutrons in it. You can excite this nucleus. We know with atoms and electrons, right? If you excite the electrons in an atom, they raise up an energy level, and then they don't...
How do you excite?
Stay there. We're all lazy, really, right? We want to go back to what we call our ground state, and that's how we produce light. And so we're all familiar with the consequences of that. But in fact, you can do it with a nucleus as well. What they do is they create an excited beryllium nucleus by they start with a lithium nucleus, and then they attach a proton to it, so of a very specific energy. So here's my lithium nucleus.
How?
Then comes a proton with very specific energy. It then forms a beryllium nucleus, which is already at an excited state. So, and that excited state.
Could you show me the setup instead of an animation?
Is compared to its natural ground state. It doesn't want to stay like this, right? And so what actually usually happens is it just disintegrates again. It just goes back to the proton goes out and you're left with the lithium. But every now and again...
I have no idea what he's talking about.
Thank you, Sergey. And thank you very much for your kind words and for the invitation to speak. So you asked me specifically to concentrate on the basic principles. So although I have a rather long title, which contains all this stuff about quantum information and decoherence, I will just put that at the end because I believe what was wanted was the basic principles. So I will concentrate on that. So the
Bell's inequality. It's a slightly obscure piece of quantum mechanics, but it turns out it really is very important to our understanding of the way the universe works. So the original paper was written in 1964 by John Bell, called On the Einstein-Podolsky-Rosen Paradox. The important issue here is that John Bell essentially took on Einstein and got the better of him.
All right.
A little bit of background about John Bell. He was from Northern Ireland, died in the early 1990s, I think, but he was quite young. He was only in his early 60s at the time, but did quite a lot of kind of fundamental work on quantum mechanics, but this is the thing that he's sort of most famous for. So here's his paper. It's a bit intense, I think is the way to describe it, in that there's lots of integral signs and things in there. And it's one of those bits of physics where I kind of struggled to understand it, but I came across this wonderful other paper by a guy called David Mermin, called Bringing Home the Atomic World, Quantum Mysteries for Anybody, which actually puts Bell inequality and Bell's theorem, which kind of underlies Bell's work, into a much more understandable framework and gives us an example that we can look at without horrible amounts of maths. David Mermin, another famous physicist, famous to most undergraduate physicists because he wrote a book with a guy called Ashcroft, called Ashcroft and Mermin, that lots of people learned their solid state physics from, so he's kind of a bit of a hate figure amongst undergraduates.
Back for some more hydrogen, I presume. Well, you've come to the right place, because that's what this video is all about. Today we've got eigenstates, we've got spherical harmonics and radial functions and the absorption emission spectrum, all kinds of good stuff. So come on in here and let's learn about this. Before we get started, I wanted to say a couple of things about this video. The format of this video is going to be a little weird. We're actually going to start by looking at...
So this is part 2 of 3. Where's part 1?
Wow, look at this beautiful hydrogen atom in the ground state. There's one proton, one electron, and the electron is as close as it can be to the proton until quantum fuzziness kicks in and the electron's kind of in this wave function of positions and you don't know exactly where it is.
Can you explain to me what's going on?
But it's something like this. Let's shoot a photon at this and see what happens.
What is that? I mean, what are you is it an animation? Is it a picture? What is it?
Whoa, look at this. It's a 200 state. Very nice. So
What do you mean 200?
now the electron is a bit farther out, a bit less bound to the proton, in a higher energy state relative to the ground state. But be careful, this is only metastable. It's going to pop back down soon. So any minute now, it's going to pop into the ground state. Oh, there it goes. And look, we got our photon back. Do you see that flash of light?
I don't know why we're getting like buffering, because it doesn't have an issue with buffering. So I don't know why it keeps getting stuck. Maybe I'll close some windows. Let me close some windows. Hold on. Closing windows, closing windows. Closing windows, closing windows, closing windows. Closing windows. A bunch of windows, many windows. Okay, I think that's enough. All right.
Light, conservation of energy. Very nice. Let's put another photon into it and see what happens.
Let me slow down further. But could you tell us what you're showing us? That's the question.
Hey, that's a 210 state. Nice. You know, that one has some angular momentum. Oh, there
That one has some angular momentum and the other ones didn't have angular momentum?
it goes. Let's take a moment to meditate on this situation.
What are we seeing? Are you going to explain?
We'll begin by examining our atom in its most relaxed form. This dazzling little pattern is one of nature's most abundant, most ancient motifs. But there's a deep mystery here. Why is it that the electron doesn't just fall into the proton?
Why should it?
If you model the electron and the proton as point particles and apply Maxwell's equations, you'll find that the electron will radiate out its energy and will end up falling into the proton in just a few nanoseconds.
Can you explain that? Why would you say that? And that's an interesting question, but also, can you explain the actual mechanics? Why does this happen? Why should it? Why do you expect it to spiral into the proton?
Seconds. But there's hydrogen out in space that's like billions of years old. So clearly our math is a little bit off, because hydrogen actually doesn't decay instantly. So what is it that stops the collapse?
I didn't. You never explained why it should collapse.
Have you ever tried to catch a quantum particle? Imagine you have one and you've caught it. You're pinching it between your finger and your thumb, and you squeeze it really tight so you know just exactly where it is. You know its position with perfect precision. Oh, well, by quantum mechanics, now you no longer know its momentum. And so it
There is no particle, there's only waves.
escapes. In quantum mechanics, you actually
That's because it's a wave. There's no way to hold on to a wave. That just doesn't, it just doesn't make sense. You cannot hold a wave.
can't perfectly localize a single particle. You can try, but it takes a lot of energy.
There is no particle, there's only a wave.
And the tighter you squeeze it, the more you localize it, the more energy it takes. If you think about it, a proton is pulling in the electron. The electron's this quantum particle. It wants to collapse all the way, but eventually there's a point where the quantum fuzziness makes it so that the
What is quantum fuzziness? What is that?
uncertainty and momentum keeps the thing from falling all the way in.
No, there's no quantum fuzziness. It's just a wave.
And so you see, hydrogen is not just an atom, it's also this portal between the world of experiment and the very strange and unusual world of quantum mechanics.
No, there's nothing strange. It's just a wave. I mean, we know it's a wave. Why do you insist that it's not a wave? Just deal with the fact that it's a wave.
That bubbles up into our world. Wait, hold up. So the electron is a quantum particle and it's
No,
all
it's a wave. Stop saying it's a particle.
fuzzy.
It's
But-
not fuzzy. It's just a wave. Why don't you say that it's a wave? I don't get it. I just don't get it. It's just a wave, nothing else. Why do you keep insisting that it's also something else? It's just a wave. Everything you're describing makes sense as long as you admit that you're describing a wave. If you insist that you're describing a particle, yeah, then nothing makes sense. Okay, then stop claiming it's a particle. It's not, it's just a wave. Why are you having such a hard time?
But the proton is just this point-like thing. How does that make sense?
It's just a wave. Everything is just a wave.
Well, it's because the proton is about 1,836 times as massive as the electron. So just to put this into perspective, the difference in mass between an electron and a proton is the difference between an elephant and 1,836 elephants. So the proton is very, very massive. Because it's so much more massive, it's less fuzzy. It is still fuzzy if you look very closely at it.
It's not fuzzy, it's just a wave. That's it. Why do these people not just say, okay, it's a wave, let's think about this wave? Why are they insisting on it being a particle?
It's fuzzy, but it's much less fuzzy because there's this inverse relationship between distance and mass.
The question is, why are some waves behaving as if they have more mass, whatever that means? Why are they more confined? Some waves are more confined than others. That's the question. That's because of the interaction with the Higgs field.
When it comes to quantum mechanics. Because the proton is so much more massive than the electron, we can do all of our analysis by assuming that the proton will be at the center of our coordinate system and that it doesn't move, it just stays put. And the electron does whatever quantum mechanical, cloudy, wavy stuff it does, okay?
Oh,
All right, let's talk about coordinates.
oh, so you said it's wavy. Oh, at least you said that finally.
Normally, I like to use Cartesian coordinates, x, y, and z, but because of the nature of this problem, it has a spherical symmetry, and so spherical coordinates fit like a hand in a glove to this problem. So we're going to use these coordinates r, theta, and phi. One thing I have to point out, I got to be careful here. So normally, I use theta as the angle around the longitude, like the azimuthal angle, and I use phi for the elevation angle. But for whatever reason, physicists working on the hydrogen atom always use the other way of defining theta
That's going to be confusing.
phi. And so I'm going to go along with that convention, but just be aware this is a little bit different than the convention that I normally use. So just to be really clear, theta is actually going to be our elevation angle. So that's going to be the angle that starts off at 0 on the North Pole and then goes down to pi, or 180 degrees at the South Pole. And then phi is going to be our azimuthal angle. So that's the angle that's going to go around the equator, 0 at the prime meridian, and then, it goes around a full 360 or full 2 pi. Okay, so now that we've defined our coordinate system, let's define some of the most important things in quantum mechanics. The first thing is the wave function. So the wave function is this complex valued function that's a
It's just an assumption. Isn't the wave function just an assumption? It's just, we're just assuming that the electron is a wave. We're literally just assuming that the electron is a wave. Because we've seen, right, de Broglie, because of Einstein. So Einstein said in the beginning, in 1905, Einstein wrote in the photoelectric effect that light is also particle-like. Okay, so light is not particle-like. I wouldn't say it's particle-light. Why did he say it's particle-like? But anyway, he said that. That's fine. And then de Broglie said an electron is wave-like. An electron is a wave. Just like light is a wave, an electron is also a wave. So people ask de Broglie, what do you mean? I'm sorry, Schrodinger. So Schrodinger gave lectures, or a lecture, about de Broglie wave duality. So people said, okay, if it's a wave, what's the wave function? What's the function that describes this wave? So Schrodinger went home for 6 months, came back with Schrodinger's wave equation. 1 second, I have an email. Not critical. So he came up with this wave equation, which all he did apparently was just say to himself, okay, the electron is a wave and it has lambda. In the wave equation we have lambda, and lambda, de Broglie told us about lambda, that lambda is I think related to energy and therefore maybe to momentum or something. Anyway, so that's the wave equation. The wave equation describes a wave that also as prescribed by de Broglie. So that's the wave equation. Now, and then they discovered, I don't know how, that the norm squared, or the square of the function, is the probability of discovering the particle. I don't know how they discovered that. That's from Born. I don't know. Born was his teacher, Schrodinger's teacher or something, or assistant or partner. I don't know. So Born said that's the Born rule, which is all very weird because the wave function is supposed to describe the wave function of the wave. So what is this probability of finding if we look for it? I don't know.
the function of both.
Nobody, I don't think anyone has a better explanation than what I just gave. Pretty much.
Space and time. So the wave function is the first thing is the wave function. So the wave function is this complex valued function that's a function of both space and time. So the wave function is given the symbol psi, and psi depends in this case on r, theta, phi, and time. Closely related to the wave function is the probability density. That is the thing that if you integrate over some volume, you get the probability that the particle is going to be in that volume. The probability density is
1 second, let me get the message. One second. Okay.
is just the amplitude squared of the wave function. When you take the amplitude squared of a complex number, you get
So this is the probability density. I don't know where they got this from and why they say it's true, but that's what Born said.
a real number. So the probability density is a real valued function.
That just means the probability that we would find it if we looked for it. Mm-hmm. Mm-hmm. All right, so let me check the time. 1 second. One second. Okay.
And it's also a function of space and time. Although, as we'll see when we solve energy eigenstates, it's just a function of space.
1 second.
The probability density is just the amplitude squared of the wave function. When you
Okay.
take the amplitude squared of a complex number, you get a real number. So the probability density is a
1 second.
function. When you take the amplitude squared of a complex number, you get a real number. So the probability density is a real valued function.
Okay. So there's no complex. Oh my God. She wants to meet at the restaurant. I don't like it. I hate it. I hate meeting at restaurants. That's the most unromantic thing in the world. I give up on this girl. This girl is impossible. That's useless. So I'm gonna drive all the way to a far restaurant, eat with her, and then leave. No, I'm not doing that. No way. There's no way I'm doing that. I don't know what to do. So go home. So I don't get it. She's coming from work directly to a date. She doesn't want to go home, relax, and for me to pick her up from home. One second. If she's not interested, then fine, we're done. I'm not going to chase her forever. Anyway, so this probability density,
And it's all squared of a complex number, you get a real number.
so it's a real number. What he says here, it's a real number, whereas the psi itself is a complex number. But every wave function is a complex number. I don't get it. Every wave function is a complex number. There's nothing new about that. A wave function is complex. What's going on with that? I don't get it. I'll have to look into that.
So the probability density is a real valued function, and it's also a function of space and time. Although, as we'll see when we solve energy eigenstates, it's just a function of space. All right, and finally, the reduced Planck's amplitude squared of the wave function. When you take the amplitude squared of a complex number, you get a real number. So the probability density is a real valued function, and it's also a function of space and time. Although, as we'll see when we solve energy eigenstates, it's just a function of space.
When we solve in a jargon state, in a dragon state, in dragon state? What is a dragon state? When we solve any dragon state, it's just a function of space and not time. What is a dragon state?
Space. All right, and finally, the reduced Planck's constant, this number h bar, you see this everywhere in quantum mechanics. It's absolutely ubiquitous. It's a measurable quantity. It has about the value of 1.05.
Why do people keep talking about it? At this point, everyone knows about this. This is just from a year ago. Everyone knows the reduced Planck's constant.
457 times 10 to the minus 34 joule seconds. This is a very mysterious number. It is what it is, and no one knows why it is. It just is.
What do you mean it's a what is a mysterious number? What is a mysterious number? I don't get it. H bar, 2 pi. What is a mysterious number? It's a constant derived from black body radiation, which I never looked into. No?
And so you'll see this in many of our equations today. It defines the relationship between energy and frequency and momentum and space and all kinds of stuff. Sort of the quantum scale of angular momentum or action. And by the way, I should mention, you know why they call it h bar? It's actually Planck's constant h divided by 2 pi. But so often you divide by 2 pi that people got tired of writing divided by 2 pi. So then they just put a bar on the h. And now everyone knows that means divide by 2 pi. So we want to figure out, what is our electron up to? What does it do? And in order to do that, we need an equation that lets us relate things like momentum and space and time. And so what we're going to do is we're going to use the Schrödinger equation, shown here. The Schrödinger equation is just the idea that if the Hamiltonian operator acts on a wave function, that's the same thing as the energy operator acting on a wave function. Now, there's a lot of confusion when people first see Hamiltonian operator. They're not sure what that is, because it's just a thing named after some guy, so who knows what it is. Well, what it is the energy written in terms of position and momentum, and we'll see in a moment exactly how to construct the Hamiltonian for the hydrogen atom.
I think I need to know Hamiltonians before I go into this lecture, so drop it. Aristotle's Ether. So this guy, Existence University, he came onto our channel. I had long discussions with him. When I listened to his videos, he seemed so smart, but when I actually was texting with him on the chat, like, he couldn't understand basic stuff. I don't get it. Like, he seems so smart when I listen to the video, but not so much when I talk to him. I don't know what's going on. It's like, I'm wondering if I ever speak to Sean Carroll and I have a discussion with him, is he going to also poop his pants? So when he's giving a lecture, he's brilliant, but when I actually debate him, he becomes like a poopy pants. He poops his pants. Let's listen a little bit.
Since the dawn of man, there has been an interest in the heavens that so effortlessly bend above us. It has captured the imagination of billions and has left us with countless yet unanswered questions, all of which stir within and amongst us. It very well could be true that very...
Let's see what she says. Okay, so she agrees. But I don't think she's taking me seriously, so anyway, I'm just filling space with her. Oh my god.
Very interest in the heavens and the goal of trying to know it is what led to all of the branches of knowledge today. After all these years of exploration and discoveries of the heavens, what is it that we have come to know about it? The objective metaphysics is existence exists, which implies two corollary axioms.
That doesn't make any sense. Existence exists? That doesn't make any sense.
Something exists which one perceives, and that one exists possessing consciousness. Consciousness being the faculty of perceiving that which exists. The axiomatic concepts of objectivism will be sufficient to get us started in understanding reality. This film provides an account of the history of physics, of those explorations and discoveries of the
Objectivism? Oh my god.
heavens, and does so by following the principles of objectivism, the philosophy created by Ayn Rand. For science and philosophy, we luckily already have some material from natural philosophy and physics, as well as from Leonard Peikoff lectures, which can help.
I don't think she created a philosophy. Maybe a little bit, but not what you think. I don't think she created the philosophy that you think she created.
Us understand the nature of reality in more depth. In a few of Dr. Peikoff's lectures on objectivism, he discussed a humorous epistemology.
So Ayn Rand, the way I see it, the way she influenced me, which is in a very powerful way. So it doesn't mean she understood it, but that's what I got from her. So the rationality assumption says that we're all egoists. That's just a given. That's just the way life is. All life is egoistic, probably because of Darwin's evolution. So we're all egoists. That's a given. Whether it's good or bad is irrelevant or meaningless. Now, Ayn Rand comes and says to be an egoist is the definition of good. You don't need to apologize, or maybe in other words, you don't need to apologize for being an egoist. Maybe not good or bad. Just you should not apologize for being an egoist. You should not apologize for what you are. This is what you are. You should be proud of what you are. You are an egoist. That's a given. And therefore, you should be proud of being an egoist. You should be a proud egoist. Now, loving yourself is moral. So morality, I mean, the word exists in the dictionary. What is moral? So I would say morality is raising the quality of life, and immorality is reducing the quality of life. So taking care of yourself, being egoistic, raising your own quality of life is therefore moral. Making sure that everyone's quality of life goes up with yours, if if theirs goes up, therefore yours goes up, that's morality. That's basically Ayn Rand's philosophy, whether she understood it or not. It's possible she never understood it that way. But that's my objectivism. That's what I got from listening to her and listening to her students. They're not always correct, but that's what I got.
Cosmological placeholder that he and Ayn Rand would use in place of the question of what existence is made of. They called it the little stuff. The little stuff is that which is where nothing isn't. It fills the universe.
This has nothing to do with it. Everything else, physics or metaphysics, I don't think that's relevant.
And can be otherwise called the ether. It is common to hear that the ether was proven to not exist, and in one sense that is true. However, it is also true that there are thousands of ether hypotheses of the last 2,000 years which have been proven to not be true. Specifically, when people talk about the ether being proved false, they are talking about the luminiferous ether. Pop science has taken the idea that the luminiferous ether does not exist to the extreme, turning that statement into no ether exists. This then drips down the pop science tubes until the message becomes, the universe is an empty void where nothingness exists and other universes might exist on the other side of vast stretches of nothingness. These types of ideas about the universe are dead wrong in every regard except one. The luminiferous ether does not exist. That is the only thing that they have correct. Note the repeated use of the word luminiferous
No, that's incorrect.
in the term luminiferous ether.
Of course, the luminiferous ether exists, and gravitational ether exists, and quantum ether exists, and these are all just the ether. Therefore, the ether exists.
The luminiferous part of that term is entirely in regard to how light travels through the universe. Quoting Einstein, the man who is said to be
Don't show particles, just show waves, and then you understand that the ether must exist. The luminiferous ether must exist.
the slayer of the ether, we may say that according to the general theory
Well, if he's the slayer, then in 1920, he's the champion of the ether, so he's neither.
of relativity, space is endowed with physical qualities.
Yeah,
It-
that's 1905. 15 years later, he took it back and he believed in the ether.
In this sense, therefore, there exists an ether.
So in 1920, Einstein, with hindsight to 1905, said that the 1905 Einstein is wrong. So there's no point in quoting Einstein 1905. He took it back.
According to the general theory of relativity, space without ether is unthinkable. For in such space, there not only would be no
Oh, this is 1920. This is the 1920 conclusion of his lecture.
propagation of light, but also no possibility of existence for standards of space and time. This film will explore the discoveries that led to
Why
this
don't you show where it's from?
new ether, the ether that replaced the luminiferous ether. This new ether can be considered to be like the little stuff that is, where nothing isn't. As we move through the discoveries that led us to this new form of ether, we are going to hold some objectivist principles in mind, so as to not wander from the purpose of checking our physics and metaphysics against reality. Starting with the axiomatic concepts that existence exists, A is A, consciousness is conscious. And the corollary statement,
These words, I mean, you can't, this is improper English. You can't say that existence exists. That consciousness is conscious. Consciousness is not conscious. A person, you could say, is conscious, or a person has consciousness. You cannot say that consciousness is conscious. You can say that the universe exists, or the universe has existence. You can't say that existence exists. That doesn't make any sense. That's like saying purple, the purple has what a color, I don't know. Anyway, it doesn't make any sense.
since things are what they are, since everything that exists possesses a specific identity, nothing in reality can occur causelessly or by chance. Which, for spacing's sake, we will simply write.
Yeah, we're done. I don't want to waste my time. Let's see what he says about general relativity.
Welcome to the History of Relativity series. Today, we will talk about the last part of Einstein's accomplishments, the formation of the general theory of relativity.
Wow, very nice audio.
Last episode, we demonstrated that the special principle of relativity was valid in the same way in which we proved that the Galilean principle of relativity was valid. That is, by showing
Yeah, I watched that. That doesn't make any sense. The complete history. I don't care. Andrew Schultz. Let's see this. Did we?
An absolutely crazy turn of events. Nearly 3,000 pagers belonging to the terror group Hezbollah have exploded all simultaneously. We're going to talk about what exactly is going on, but more importantly, what lessons it has for the United States. I'm Paul, U.S. Army combat veteran. Talk about this completely preposterous story. That's right, Hezbollah, the terror group in southern Lebanon, who's been escalating their rhetoric against Israel over the last several months, and it's looking increasingly like Israel's planning on conducting some level of military operation against them, have had their pagers blow up. Now, you might be thinking to yourself, one, pagers? And it actually makes a fair amount of sense, right? They know that Israel has a very sophisticated high-tech intelligence agency, or agencies, plural. And so therefore, they actually seem to have decided to go old school, right? Pagers can receive signals, but they don't do any broadcasting on their own. That means they're perfect tool to get in touch with fighters. And right, in a way that cell phones aren't, right? Cell phones are very hackable and very traceable. Again, classically, if you've ever watched any true crime show, you know that they can always trace the victim's cell phone through the days of activity. And so, as a security measure, a lot of Hezbollah personnel were likely issued pagers or beepers. The idea would be that it would insulate.
So now all the enemies of Israel are terrified of any technology. So what are they going to use next? Like, they went back to pagers. What's next? What are they going to do next?
Them from electronic surveillance. And while it did, it also apparently turned into bombs. So the attack was highly unusual. The Lebanese government, of course, blamed Israel, examining all the facts, available data, and information about the heinous attack that took place this afternoon. This is a statement from the Lebanese government. We hold the Israeli enemy fully responsible for this criminal aggression. Now, the Israeli military didn't say one way or the other, but they have in the past used exploding cell phones as another tactic. Now, one U.S. official who wasn't authorized to speak publicly said Israel informed the U.S. they carried the attack after it was over. Right? The thing that is strange, there's a couple of things we're strange about this. The first is that the pagers, while they seem to have wounded a lot of people, it's not clear what the ultimate military objective was. The reason I say this is because these pagers going off, while they wounded a lot of people and were certainly harmful and killed 8, killing 8 people and wounding 3,000 or 4,000 is not really that effective a weapon system. While in most cases,
No, this is by far the most effective weapon system. I mean, you're targeting only combatants even at home, even in the market, everywhere. This is the most targeted attack because Israel keeps getting blamed for killing civilians. So this is super targeted. It's going to be very difficult to blame Israel for genocide. This is clearly not a genocide. So it's very effective. This went after the very highest ranks, including the Iranian ambassador, who might have been one of the actual targets. I don't know. Anyway, this is very effective. I mean, what do you think the purpose of any operation is? At the end of the day, you want to deter your enemy. You want to let your enemy know, don't be my enemy, be my friend, because as your enemy, you're going to suffer. As my friend, you're going to be happy. So don't be my enemy, be my friend. Oh, you're not going to be my friend, you're going to be my enemy. Well, here is a taste of the things to come. Enjoy. That's it. It's a message.
there were a lot of injuries.
It's like when a parent says to the child, don't misbehave or I will have to resort to punishing you. What's the punishment? Well, it could be that I'll be upset. I'll be unhappy. You're going to make me unhappy. So don't make me unhappy. Oh, you are going to make me unhappy. Well, here, I'm going to be unhappy.
It seems like, just based on the fact that it doesn't seem like these were like a grenade planted inside the pagers. These are small explosives. And so the result was more light wounds than anything else. So then you're left with this real question of why. Like, yeah, I get it. It was a pretty big flex. And that may actually be part of the strategy. But before we talk about exactly why the Israelis did this, I want to say that if you feel like you need to reach out and really energize yourself, you don't need to have a lithium-ion battery explode. Instead, you may be better off with just a little bit of caffeine. That's why you want to check out Strike Gum in order. So it's a cough medicine. Strike Gum's for you. That's why Red Bull or Amp Energy concentrated into a single. More interesting question here. I think there's two reasons. The first is as a message, right? Hezbollah's rhetoric has been ramping up. Israel really feels like there's a good chance it may have to divide its military to combat both Hezbollah in the north and Hamas in the south. And so as a result, they need to intimidate. They need to tell Hezbollah that this won't be a one-sided affair, that their fighters are deeply at risk, and that they've misassessed that the Israeli military and intelligence apparatus is highly capable of targeting them. And so by using this kind of exploding beepers, yeah, it's likely going to injured a lot of folks. But more important is that it sent a message. It said to everyone who has these beepers, because remember, if you're not a member of Hezbollah and you're not being targeted by the Israelis, it's probably not a problem that you probably don't need a beeper, right? So the fact that these individuals had these beepers sends out a message from the Israelis. It says, listen, if you're a member of Hezbollah, we can find you and we can hurt you, right? To a man, to a person. And that is the real message here. I think the other aspect is that the pagers are used for communication, right? They're to alert other fighters that when something is happening, right? They're likely some kind of readiness or alert system that when they receive a certain type of message, the fighters know that it's time to get into positions or report to their command or something like that. And so by taking out every one of these pagers, you have briefly damaged the Hezbollah alert system. You've damaged their communications. And usually, though, when you take out a communication system like this with this extensively, you do so hours before launching a major attack. So it'll be very interesting to see if this is a precursor to a larger attack.
No. Israel's not doing anything.
But there's also a lesson for
Israel has been very carefully targeting militants everywhere, basically since October 7th, and ramping up. Israel has been ramping up, attacking, but targeting through targeted attacks, not just general warfare. Very little actual general warfare, much more intelligence-based targeted attacks, and still ramping up.
The larger military, the universe, right? Trevor Ball, former explosive ordnance disposal tech for the U.S. Army, said he believes explosives must be planted in the pagers. Again, I maintain that you can do the same thing by overheating a lithium-ion battery. Pagers supposedly have small amount of high explosives that were remotely initiated, and widespread nature of the pagers exploding indicates that the supply chain of the pagers was compromised at some point. And that, I think, is one of the biggest lessons here for Western militaries, is that a lot of times we sit there and we go, oh, there's a perception that, it's not a big deal. We spend...
That's why, this is why it's important to use off-the-shelf and distributed systems, and the single point failure. These are all problems. So that's the problem with dictatorships. Dictatorships have this problem. The Western powers use much more distributed systems. They buy Microsoft computers, and they buy just off-the-shelf stuff. So off-the-shelf is just safer. And Donald Trump used to go to McDonald's, or goes to McDonald's, because it's cleaner. It's the cleanest, and it's the safest. And when the president flies and they need to buy food, they wake up in the morning, they just go to a random local market. They just go to the market. How are you going to poison the president if the cooks go to a local market and just buy food? It's very difficult. Anyway.
We spend a lot of money on high-tech equipment, and that's because we make it almost always here in the U.S. or in other trusted allies countries, and it drives up cost a lot. But there's a reason, right? And that reason is because the U.S. military's adversaries are very much willing to insert. Momentum is...
So the idea that light has momentum even without mass, I mean, this explains a lot of things. So the question is, what is mass? But through this interaction, through electromagnetic radiation, electromagnetic interaction, we can move an electron. We can actually move an electron. So that's incredible. What else did we not go over? Which is fastest equals mc squared. Let's see this. I already watched this once, but I wasn't paying too much attention.
The most intuitive derivation of E equals mc squared. It's how Einstein originally derived it in 1905. Not only will we see exactly how the constant speed of light inevitably leads to the mass energy equivalence, but we will visualize all the necessary math, step by step, from scratch. So, if you're ready to relive this historic moment, let's begin. So Einstein, where do we start? Well, Einstein says, imagine we have a radioactive atom, and it has some energy in it. For the sake of simple numbers, let's say it has 10 units of energy in it. And I love simple numbers. Thank you, Einstein. Now, Einstein says, if you wait for some time, let's say it shoots 2 photons of light, exactly in the opposite direction, each carrying 1 unit of energy. And I'm like, wait, why did you imagine 2 photons going in the opposite direction? Well, Einstein says, well, if you had only 1 photon, then there'll be some recoil due to momentum. And so, just to make sure that the atom does not recoil, he's making sure there are 2 photons going in the exact opposite direction, ensuring that the atom stays put, it is still at rest. Okay, pretty good. So Einstein now asks, what is the new energy inside the atom? Well, if it has lost 2 units of energy.
It's incredible that a lot of modern physics is just thought experiments. But actually, Galileo came to the conclusion that Aristotle was wrong, that all objects accelerate at the same rate. That was a thought experiment.
1 unit in each photon, then it should now have 10 minus 2, 8 units of energy in it. And this is perfect. And one last step Einstein says is, his friend is piloting a rocket and she's moving towards the right at a constant velocity v. Einstein now jumps into that rocket. And now he asks, from this rocket's reference frame, what now is the energy of this atom? And at this time I asked Einstein, is it ever going to end? Einstein says it's going to end. Okay, this is the last step he says. All right, so from the rocket's perspective, the rocket is not moving. In fact, it feels like the atom is the one that's moving towards the left with velocity v now. And therefore, along with that 8 units, it also has an additional kinetic energy. And so we would say, now from the rocket's perspective, the atom should have the energy of 8 plus half mv squared. And that now is the energy that we would assign to that particular atom. But now here's the question that Einstein asks. His friend has always been in the rocket, moving with velocity v. She has been seeing the atom.
Okay, this is really not that interesting. Is it? Is this the way Einstein derived it? Let's start over.
This video is probably the most intuitive derivation of E equals mc squared. It's how Einstein originally derived it in 1905. Not only will we see exactly how the constant speed of light inevitably leads to the mass energy equivalence, but we will visualize all the necessary math, step by step, from scratch. So, if you're ready to relive this historic moment, let's begin. So Einstein, where do we start? Well, Einstein says, imagine we have a radioactive atom and it has some energy in it for the sake of
Okay, so it's a radioactive atom. Okay,
simple numbers. Let's say it has 10 units of energy in it. And I love
10 units of energy. Okay.
simple numbers. Thank you, Einstein. Now, Einstein says, if you wait for some time, let's say it shoots 2 photons of light, exactly
Okay, so it shoots 2 photons of light,
in the opposite direction, each carrying 1 unit of energy. And I'm like, wait, why did you imagine
1 unit of energy each. Okay.
2 photons going in the opposite direction? Well, Einstein says, well, if you had only 1 photon, then there'll be some recoil due to momentum. And so just to make sure that the atom does not recoil, he's making sure there are 2 photons going in the
Good, no recoil.
exact opposite direction, ensuring that the atom stays put, it is still at rest. Okay, pretty good. So Einstein now asks, what is the new energy inside the atom? Well, if it has lost 2 units of energy, 1 unit each in each photon, then it should now have 10 minus 2, 8 units of energy in it. And this is perfect. And one last step Einstein says is, his friend is piloting a rocket and she's moving towards the right at a constant velocity v.
Okay, this is Einstein's friend. She's moving to the right at v.
Einstein now jumps into that rocket. And now he asks, from this rocket's reference frame, what now is the energy of this atom? Now this time I ask Einstein, is it ever going to end? Einstein says it's going to end. Okay, this is the last step he says. All right, so from the rocket's perspective, the rocket is not moving. In fact, it feels like the atom is the one that's moving towards the left.
So the rocket has a constant velocity, so it actually does not feel like it's moving. So as far as the rocket is concerned, Einstein now looks at the particle and says, oh, it's moving to the left at v. Okay.
With a velocity v now. And therefore, along with that 8 units, it also has an additional kinetic energy. And so we would say, now from the rocket's perspective, the atom should have the energy of
Okay, now it also has kinetic energy, 1 mv squared. Okay.
8 plus half mv squared. And that
Plus 8. Okay.
now is the energy that we would assign to that particular atom. But now here's the question that Einstein asks. His friend has always been in the rocket, moving with the velocity v. She has been seeing the atom even before it shot the photons. So Einstein asks, what does the calculation look like from her point of view? What would be the final energy of the atom?
Okay. So what's her calculation? Okay. So his calculation is this. Her calculation. So Einstein saw the 2 photons leaving simultaneously and making it go from 10 to 8. But what did she see? Okay.
As seen by her. And of course, I would say, like Einstein, she should get the same answer, right? Because eventually, both you and her are in the same frame. So both of you should agree, you're looking at the same atom, so you should agree what the final energy of the atom is. And Einstein says yes, but let's just do the calculation from her frame and let's see what we get. All right, let's do that. So from her frame, she always appears to be at
Okay. From her frame of reference, she always appears to have been at rest.
rest, and she sees the Einstein and the photon, sorry, not the photon, the atom to be moving
Right.
towards
She sees Einstein and the photon or the particle moving at v to the left.
the left with speed v. And therefore, from her perspective, the initial energy of the atom was 10 plus half mv squared because it's already moving.
Right. Initially, it's 10 plus 1 mv squared. Okay.
And then she sees that atom shoot 2 photons of light, and therefore
Right. 2 photons of light.
the energy of the atom now decreases by 2, so it becomes 8 plus half mv squared. And I'll tell Einstein, look,
So now the particle is 8, so they're in complete agreement. Okay.
like I said, we get the exact same energy as before. She also says it's 8 plus half mv squared. You also said it's 8 plus half mv squared. Everyone is happy. That's just like, what are you asking? But Einstein says, Mahesh, you forgot something. What's that? Doppler effect. Einstein reminds us that light also has wave properties. And so if you were to look at the atom when it's at rest, this is how the waves would look like. But now when that same atom is moving, look at it. Look at it. It's exactly the same atom giving out the same number of waves per second. Let's look at it together. Look at that. It's giving out the same number of waves per second. But because the atom is moving, what do
The same number of waves per second? What do you mean? Waves of what?
we see? Well, we see that in the front of the atom, the wavelength has squeezed. And so the frequency is higher. The waves are closer. And
Waves of what?
behind the atom, the wavelength has stretched. So the frequency is lower. And therefore, if from the stationary frame, if the photons had these frequencies, then when you're looking at that atom from the moving frame, from the rocket, Einstein's friend, she wouldn't see the same frequency of the photons. In fact, she would see over here a higher frequency of the photons.
What do you mean see? What do you mean see? This is quantum mechanics already. So you don't see. You have to interact. Let me see the battery. Oh, it's 0. Let me charge the battery. And this phone. It's incredible that this knowledge is available on the web, but also there's no way to communicate. But when you go to class, you can't stop the teacher midway and tell them, what do you mean? In my experience, it's impossible. You can't really question them in class. Anyway, so I don't know what you mean by a Doppler effect. Well, what are these waves? What? Why would an atom be waving? Unless you're saying it's not an atom, unless you're saying it's something. If you're saying it's not an atom, let's assume it's not an atom. It's some device. It's some object. It's some macro object. Now also has Doppler effects. So it's giving off light. We can see it. And maybe it gave off these two particles, not subatomic, but actual macro scale particles. Let's assume that. I don't know.
Called blue shifted. Now, it doesn't mean Einstein says that the photon is not really blue in color. It's just called blue shifted because and the frequency is higher, it's moving towards the blue end of the spectrum. That's what it means.
In the 1905 paper, I don't think there is photons or anything like that.
Then this representation we're showing it as blue. But she will see a higher frequency photon on this side, and on the other side, she would see a redshifted, lower frequency photon on the other side. That's what Einstein's friend would see. Okay, Einstein, why should I care about the frequencies? Because
So Einstein, the stationary observer sees them both yellow, whereas the moving observer sees this one blue shifted, this one red shifted.
Einstein says, remember, energy of a photon is equal to h into its frequency. Planck's equation. So energy depends on the frequency.
So this is using Planck's formula. Planck's equation. Energy depends on frequency. Okay.
This means if these two photons had the energy 1 in 1 unit, then these two photons will not have the energy 1 in 1 unit. This blue photon will have energy higher than 1. This redshifted photon will have energy lower
This is 1 plus, this is 1 minus. Okay.
than 1. We didn't account for that. Okay, so Doppler effect is interesting. All right, my first counterattack to this is, Einstein, well, since this photon will have energy more than 1 and this photon will have energy less than 1, won't it just work out that the total energy will become 2? And Einstein says, no. I mean, we'll have to actually do the math to figure this out, which we will do. But even intuitively, you can see, just from this diagram, you can kind of see over here, the wavelength is squeezed so much that the frequency is almost double in this particular animation. So if the frequency is double, this photon already has twice the amount of energy. So look, that photon already has 2 units of energy. Now this photon, redshifted photon, will have energy less than 1, sure, some energy, let's say 0.2 for the sake of numbers. And look, because this blue shifted photon already is dominating, the total energy becomes 2.2 higher than the total energy that we saw earlier from the rest frame. And this would be true, Einstein says, if you do the math for any velocities. It doesn't matter what velocity we're
Right. And certainly when you go to a very high velocity, so you're going to get super high frequency here, much more than just the addition of these guys. This will go to infinity. There's no limit to how you can squeeze this.
moving at, if you correctly look at the Doppler shifted energies, the total energy will always be more than the energy that you find from the rest frame.
Yeah.
And of course, as we do the math, we'll actually figure this, we'll see this as well. Okay. So what does this mean, Einstein? Well, this means if we go back over here, we made the mistake that she would see the photons of having the same energy 1 in 1 unit, which is wrong. If you take those same numbers, she would instead see a blue shifted photon and a red shifted photon with a total energy of 2.2.
Okay, so you would see a blue and a red shifted photons. Okay. So the total energy she has is higher than what he has.
From her frame, this atom lost 2.2 units of energy, and therefore she would.
Right, the atom lost 2.2, where this guy only lost 2. So this atom must be under 8. This is exactly 8. Okay.
Claim that the final energy of this atom would be 10 minus 2.2, which is 7.8 units of energy, and therefore from her frame, she would suggest that the energy of the atom would be 7.8 plus half mv square, going towards the left. But wait a second, Einstein. These two energies of the atoms are supposed to be equal to each other, right? Because they are now in the same frame together, they're looking at the same atom. And Einstein says, yes, they're supposed to be equal. But how can that be equal? This equation says that 8 should be equal to 7.8, which is impossible. And Einstein says, Mahesh, remember how to approach special relativity? You don't approach it with a closed-mindedness and say it's impossible. Instead, you ask yourself, what needs to happen in order for it to be possible? Okay, all right. What needs to happen for this equation to be possible? Well, let's look at it, says Einstein. If you simplify a little bit, you get 8 minus 7.8, 0.2 on the left-hand side, plus half mv square equals half mv square. And I'm saying left-hand side by 0.2. I'm saying the velocities have to be exactly the same because they're looking at exactly the same atom, right? The same atom.
So the mass has to change.
They're moving at the same speed, so the velocity must be the same. And Einstein.
So what? So after it only has this energy, or before? This is the 0.2. So let's look at this. Oh, so this equals that. in the beginning it's 10, whereas this is 10 plus 1 FMV squared. Can't believe these thought experiments actually ended up giving correct predictions. This is so confusing. So this guy saw 10. This is Einstein. He saw 10. But she was moving, so she saw 10 plus 1 FMV squared. Dermatologist kills wife after her concerns about cross dressing. That's him. That's a guy. So he was a cross dresser. His wife found out. She was worried about that. I mean, why would you be worried? Why not just tell him, look, if this is what you want, you know, I'm not into that, but just we can talk about it. I mean, so you always have to be very careful. Like when you're about to expose someone, you have to be very careful that they could go over the edge. People are very sensitive to their privacy. Anyway, so before it was 10 and 10 plus 1, it wasn't, they didn't agree before. And then it became 8, 1 and 1, whereas this must have, she, in the moving frame, she must have seen this drop from 10 to 7.8. This is what she must have understood. And then they're in the same frame of reference, and they both agree there is V, so they both agree there is 1 FMV squared. 1 second, let me get a message. Let me just see, urgent. But I need to get this done. Let me see if I can find it. Let me see if I can get this done. I sent it to her already. One second. This is it. Why is there? I think this is it. Can I reply? No, that's not it. This? No. 1 second, 1 second. This. So let me. One second. 1 second. One second. Is this it? Let me check. No, 1 second. Yeah, that should be good. Okay. All right. So what is Mahesh saying? So over here, so they're looking, now they're both in the spaceship. So they both agree on the velocity, not maybe on the mass. What about the 8 and 7.8? I mean, she sees 8. And what do you mean? I don't understand. I mean, they must agree now. Well, she remembers that it must be 8. No, he remembers that it must be 8. She remembers that it must be 7.8. So bring over the 7.8, then he might as well think that it weighs 0.2 or has energy of 0.2 plus 1 FMV squared. And she thinks it's also 1 FMV squared, but he thinks there is this extra energy. So they disagree on this extra energy. How do we resolve it?
Agrees, of course, the velocity
She just thinks that it lost more energy.
is the same. This means there's only one possible conclusion if this equation has to be valid. That is, the mass on the right-hand side should somehow be bigger than the mass on the left-hand side. But I'm like, how can that be, Einstein? Both of these are the masses of the same atom. They're looking at the same atom. Why would they conclude the two different masses?
Yeah, I mean, they're looking at the same object. How could she think that it's more massive? I mean, they're conducting tests. She thinks it's more massive. How can that be?
And Einstein says, Mahesh, look carefully. This mass on the right-hand side is the mass of the atom before it shot the photons. And this mass on the left-hand side is the mass of the atom after it shot the photons. Which means this equation is saying that the atom must have lost mass because of shooting the...
Wait, what do you mean? Isn't this just his perspective, her perspective? What do you mean before and after? I'm lost. 1 second. Let's go back. Let's trace our steps.
Any velocities. Doesn't matter what velocity we're moving at. If you correctly look at the Doppler shifted energies, the total energy will always be more than the energy that you find from the rest frame. And of course, as we do the math, we'll see this as well. Okay. So what does this mean, Einstein? Well, this means if we go back over here, we made the mistake that she would see the photons of having the same energy 1 in 1 unit, which is wrong. Now, if you take those same numbers, she would instead see a blue shifted photon and a red shifted photon with a total energy of 2.2. So from her frame, this atom lost 2.2 units of energy, and therefore she would claim that the...
So from her frame of reference, from her point of view,
final energy of this atom would be 10 minus 2.2, which is 7.
She saw 10 minus 2.2, which is 7.8
units of energy. And therefore, from her frame, she would suggest that the energy of the atom would be 7.8 plus half mv squared going towards the left. But wait a second, Einstein. These two energies of the atoms are supposed to be equal to each other, right? Because they are now in the same frame together. They're looking at the same...
Now they're in the same frame, looking at the same object. This has nothing to do with before and after.
Atom. And Einstein says, yes, they're supposed to be equal. But how can that be equal? This equation says that A should be equal to 7.8, which is impossible.
This is the accounts of two different people who experience different things. This is not before and after.
And Einstein says, Mahesh, remember how to approach special relativity? You don't approach it with a closed-mindedness and say it's impossible. Instead, you ask yourself, what needs to happen in order for it to be possible? Okay, all right. What needs to happen for this equation to be possible? Well, let's look at it, says Einstein. If you simplify a little bit, you get 8 minus 7.8, 0.2 on the left-hand side.
What do you mean if you simplify? This is his point of view, this is her point of view. What do you mean if you simplify?
Plus half mv square equals half mv square. And I'm saying, Einstein, look at it. This equation is saying that the half mv square on the right-hand side should be more than the half mv square on the left-hand side by 0.2. I'm saying the velocities have to be exactly the same because they're looking
Yeah, they're looking at you just said they're looking at the same object. This is not before and after.
at exactly the same atom, right? The same atom, they're moving at the same speed, so the velocity must be the same. And Einstein agrees, of course, the velocity is the same. This means there's only one possible conclusion if this equation has to be valid. That is, the mass on the right-hand side should somehow be bigger than the mass on the left-hand side. But I'm like, how can that be, Einstein? Both of these are the masses of the same atom. They're looking at the same atom. Why would they conclude the two different masses? And Einstein says, no, look carefully. This mass on the right-hand side is the mass of the atom before it shot the photons.
What are you talking about? What are you talking about? Before it was 10 plus 1 half mv squared. Then it was 7.8. This is energy. This is some energy level that is not associated with the mass. So it's 7.8 plus 1 half mv squared. So we were always assuming that that by losing energy, it didn't lose mass. That was the assumption, that energy and mass are separable. So the m is the m before. But this m is also the m before. Both m's are before. Now, now we just want to come and say, no, it must have changed. So this is the m after, which both must be influenced by losing energy.
And this mass on the left-hand side is the mass of the atom after it shot the photons, which means this equation is saying that the atom must have lost mass because of shooting the photons. In other words, look at this. This is the history in the making, folks. This equation is staring at us and saying that the fact that the atom lost energy means it must have lost mass. That's the only possible.
Okay, so that's necessarily the conclusion, that by losing energy, you must lose mass because of the Doppler shift. Because when you lose energy, even though there is no mass, there's just energy. 1 second, message. So because, well, at least because of the Doppler shift. So 1 second. I'm so tired. This is draining my energy. So 7 okay, so this is 10 and 8. So you agree that it lost energy, but it must lose more and more and more and more and more energy compared to if it's stationary. So because it's moving and the Doppler shift translates to energy, So this must be going, this must have lost more than this. This energy must have come from somewhere.
Conclusion. Whoa. And what I love about this derivation is that we didn't start with any assumption. We didn't think about its mass or anything. But the fact that Doppler effect gives you more energy in the photons from the moving frame means there's only one conclusion, that losing energy means losing mass. Whoa. But wait a second. I promised you complete intuition. So I have a question. Well, this happens due to Doppler effect, right, Einstein? Well, the Doppler effect happens in all the cases, in all the waves. So why do we only see this in light in special relativity? What Einstein replies to this is what truly blows my mind away, because there's a subtlety in the Doppler effect of all the other waves. So if you consider, for example, the waves produced by a speaker, the sound waves, the big difference is that sound waves require a medium to travel. And therefore, now if I blast off into a rocket towards the right, sure, now I will see the speaker moving towards the left. But
No, light requires a medium too. That cannot be relevant.
along with that, the medium is also going towards the left with the same speed. So there's a wind towards the left with the same speed. What happens because of that, Einstein? Well, Einstein says now, because of the wind, the velocity of the sound towards the left gets an additional boost by the exact same amount because of
What? Wind? What are you talking about? Doppler shift needs wind?
now I will see the speaker moving towards the left. But along with that, happens in all the cases, in all the waves. So why do we only see this in light in special relativity? What Einstein replies to this is what truly blows my mind away, because there's a subtlety in the Doppler effect of all the other waves. So if you consider, for example, the waves produced by a speaker, the sound waves, the big difference is that sound waves require a medium to travel. And therefore, now if I blast off into a rocket towards the right, sure, now I will see the speaker moving towards the left. But along with that, the medium is also moving towards the left with the same speed.
Okay, so what? Let me reduce the speed. This is important.
Blast off into a rocket towards the right, sure, in the Doppler effect of all the other waves. So if you consider, for example, the waves produced by a speaker, the sound waves, the big difference is that sound waves require a medium to travel. And therefore, now if I blast off into a rocket towards the right, sure, now I will see the speaker moving
Oh my god, I'm falling asleep. This is so boring. Oh, but this is really important. What can I eat to not fall asleep? Oh my god. Maybe I'll chew gum. Oh my god. Can I mute to chew gum? I came here to chew gum and let me see. Is this mute?
So if you consider, for example, the waves produced by a speaker, the sound waves, the big difference is that sound waves require a medium to travel. And therefore, now if I blast off into a rocket towards the right, sure, now I will see the speaker moving towards the left. But along with that, the medium is also moving towards the left with the same speed. So there's a wind towards the left with the same speed. What happens because of that, Einstein? Well, Einstein says now, because of the wind, the velocity of the sound towards the left gets an additional boost by the exact same amount. Because of that, it does not allow the wavelength to shrink on the left-hand side.
Einhorn, Finkel, as Einhorn, Einhorn and Finkel. With all due respect, what do we think about this?
I wasn't there for that. I didn't see it.
Go ahead and hit your reefer out of that bong. It's not a
Oh
problem.
yeah.
Whoa. I'm confused. Wait.
In the meantime, let's bring into the conversation some of our friends to help us make sense of this and break it all down. That's, of course, national security analyst and expert and retired Marine intelligence officer Hal Kempfer and David Daoud there at the Foundation for Defense of Democracies. Gentlemen, thanks for being with us tonight. Hal, I'll start with you. Did Israel just try to take out all of Hezbollah in this?
Well, Andrew, not exactly all of Hezbollah, but it's a pretty big strike. I've heard various estimates today. 9 people killed, 2,700 or 2,750. I've heard a more recent estimate that said there could have been 500 people seriously or critically injured in this attack, and about up to 4,000 injured. Now, this is a cross section of mid-level to upper-level Hezbollah. That's a lot of Hezbollah personnel, a lot of Hezbollah leaders, if you will. They're involved. To give you an idea of how high up this went, the Iranian ambassador to Lebanon was injured in this attack. So this is actually kind of throwing them for a loop. You have all these people who are taken out of place, if you will, with either injuries, some critical, in some cases, some deaths. And then, of course, the other part is now they have to go back to some other form of communication, which they feel would probably be implicitly vulnerable. And so it really has a huge effect on Hezbollah organizationally in an ability to command, control, and most of all, to communicate.
All right, David and Hal, I want to show the viewers this video capturing the moment of one of these explosions today in a supermarket in Lebanon. We're also being told that Lebanese hospitals are just being swamped, just being flooded right now with people going there to get treated for some of their injuries here. Let's just watch this and listen to this, and then we can comment and opine on what we just saw. Okay, so David, you just saw it there. There was an explosion at his waist, and he dropped to the floor. Looks like this is in some type of supermarket or bazaar here. David, what are you hearing from people in Lebanon at the moment?
Well, I guess it depends on who you're asking. Generally, the sentiment is the government is condemning this. Some of the parties that have been allied with Hezbollah are condemning this. The parties that are opponents of Hezbollah seem to be silent. So if we're expecting a Lebanese response that would be celebratory, I think we're banking on the wrong thing. Lebanon is condemning this at the Security Council as an act of Israeli aggression, even though, as you can see in the video, this was not an indiscriminate attack. This was very precise. The people who were surrounding this Hezbollah operative were not even so much as injured. Now, this wasn't the case in all cases. There's a 9-year-old girl, if I recall correctly, who was tragically killed. But overall, 11 people killed so far. One of them we see was a civilian, and the others are Hezbollah operatives that Hezbollah itself has announced. This was a very precise strike. Nevertheless, this is going to, I would not imagine this would be received favorably in Lebanon maybe in certain circles, but not a critical mass that would necessarily be celebrating this.
So I just wanted to kind of ask this question. This is open-ended. And Israel hasn't claimed responsibility for this just yet, but if they do, and maybe when they do, how did they pull this off? How does a pager or thousands of pagers spontaneously combust simultaneously at the same time all across Lebanon, directly targeting these Hezbollah fighters, these, what would you call them, mid-level managers, so to speak? How does someone pull that off?
Well, Israel has a history of excellence, if you will, in covert operations, and this is one of the more, I have to say it's one of the more brilliant operations I've ever seen, and that they got somehow in the supply chain. The latest I've seen is about 5,000 pagers basically be used as communication devices to replace the reliance on cell phones, which they feel, and also the hardline phones, which they felt had been compromised because of Israeli signals intelligence capabilities. So they went with these pagers, a little bit more simple technology, and some would say a little bit more analog, although I believe they're digital pagers, but still, nonetheless. Now, somewhere in there, they intercepted them, and as near as anyone could figure out, that these, a lot of people thought they were just hacked and the lithium batteries exploded. Well, that's not quite how lithium batteries react. They do run away thermal effects, but not like an explosion like this. They think these batteries had about 20 grams of PETN explosives in there, and they were triggered by something. And based on the injuries that are coming in, it literally sounds like there was a mass page that went out about 3:30 in the afternoon. A number of people had picked up the pagers and were looking at them when they exploded. And they know that because of the facial injuries and the injuries to their hands, where a lot of people lost fingers. In other cases, people who are wearing their pagers on their midsection and their pockets suffered injuries in that area. And so somewhere along the line, the Israel, if it was, I'm assuming it's Israel. I don't know of anybody else who would have done this, but they got into that supply chain and they did something, either put in batteries or did something with the pagers themselves to turn them into small explosives. This is not a brand new concept. In 2009, Al-Qaeda did something like this in Saudi Arabia, where they actually had much more explosives, almost a pound of PE-10 explosive, with a suicide bomber who had placed it inside his body, inside his rectum, and there was a chip that was in there, and when he called his compadres, his comrades to turn themselves into the Saudi authorities, that they triggered that chip, which then set off the explosive in an attempt to kill a very senior Saudi prince. So the concept is not new. This particular application is rather new.
So, Hal, you're saying that the concept may not be as sophisticated as so many are describing here, but the scope of it is where the sophistication comes in here. David, I want to get to you as well. We know Israel is deeply penetrated inside the Iranian regime. We know they're deeply penetrated into Hamas. We know they've been extracting and gathering intelligence from Hamas fighters they have captured. Did we know Israel was as deeply penetrated inside the upper echelons, the rank and file of Hezbollah, like we just saw today? If Israel did this and if Israel claims responsibility, that is a stunning level of penetration.
When there have been indications over the past 11 months that this was the case, if we look at the number of Radwan force commanders, Hezbollah's elite commando unit, that have been killed over the past 11 months, some of these guys are being killed in real time on motorbikes, driving around South Lebanon in their cars. So the Israelis have the ability not just to find out who these people are when they rely on anonymity. They're not exactly walking around and identifying themselves as Radwan force commanders, but they're able to find exactly their location in real time. Let's go back to a month and a half ago. I think it was now July 30th, if my math is serving me correctly, when the Israelis assassinated Fuad Shukr, Hezbollah's top military commander in Beirut.
again, this was a man. It's not for nothing that Hezbollah's military commanders keep earning the moniker of Ghost. They again thrive in anonymity. They tend to operate clandestinely, and yet the Israelis were able to lure this man to his death with a cell phone call, as far as we can tell, based on open source open source reports. With a cell phone call that happened minutes before his death, they lure him to a building in the middle of Beirut, or middle of Hezbollah stronghold Beirut in Harat Tahrir, and then they dispatch him with a targeted airstrike. So there has been indication that Israel is capable of penetrating Hezbollah that deeply. Today was perhaps the most blatant, spectacular example of that, however you want to put it.
Yeah, and of course, we know Hezbollah is blaming Israel for this. We're not going to give their statement really any time here. But, Hal, I want to ask, what's the subtext to all of this? What's the meta meaning? David brought up that the IDF took out their number 2 military commander, Fouad Shakur. We also know that deadly Hezbollah attack against the 12 Druze school children on the soccer field earlier this summer as well. We know that Israel wants more than 150,000 displaced civilians who had lived in the north near the Lebanese border. They want them back in their homes. What is the meta meaning to this today?
I think there's a meta meaning. The meaning goes to Hezbollah and indirectly to the Iranians, that in the long run, they're not going to prevail, that the Israeli intelligence services, their covert operational capability is far broader than they probably assess, that they're able to do things which can literally, in this case, it doesn't bring Hezbollah to its knees, but from a command, control, and communications perspective, it has a broad impact across the way. One interesting point about this, if you look at 4,000 people being impacted in such a way, being whether they're seriously injured, critically injured, killed, or just injured, that has such a broad ripple effect across Hezbollah, all the families that are associated with Hezbollah. It is a bit of a wake-up call in terms of it makes them feel vulnerable, that the IDF, that the Israelis can somehow target them in these very sophisticated means, much like David mentioned, that very sophisticated direct strikes, direct action stuff, and this literally blowing up, not a drone strike, not an air strike, not a missile strike, but literally blowing up in their pocket or on their belt or holding in their hand right in front of them. The psychological impact of this cannot be understated. This is one of the more brilliant psyops things I've ever seen.
Yeah, the psychological blow to the psyche of these people, the smallness of it. It's so mundane. You just wearing a pager and you hear it. I mean, that's I think what is so jarring and what is just so spectacular to behold here. And it all happens simultaneously. David, you and I talk so much about escalation. What was Israel responding to that Hezbollah did? You can make the argument, and many have, and I think it's accurate, that Israel has also been at war with Hezbollah since October 8th, if you will. We're nearing the year anniversary of the October 7th Hamas attack here. But in the immediate aftermath of that, Hezbollah started firing rockets into northern Israel here. But what is Israel responding to here? Are we going to hear from U.S. officials there, from the Biden White House, that they're concerned this could escalate tensions even more into a regional wider war? I sound like a broken record here. It seems and it feels like Groundhog Day because we're talking about this again. The escalation question, is it going to be there in this story, David?
I mean, absolutely. Anytime there's something this significant, there is a risk of escalation. The Israelis, you're asking what they're responding to. Shin Bet earlier this morning, our time, had disclosed that Hezbollah had been attempting to assassinate a former Israeli security official in Israel with an explosive that would have been remotely detonated from Lebanon. So it seems like the Israelis engaged in their own remote detonation, a mirror attack, maybe a message there that whatever you can try to do, we can actually do better. Now, Hezbollah, this pushes them into a corner because in addition to the psychological impact on the organization itself, this is a public humiliation for Hezbollah. This punctures the image of invincibility that the organization has created for itself, that serves as the draw for many Shiite Lebanese and many other Lebanese to support the organization. The idea that Hezbollah can deter or defeat Israel militarily, that it has the upper hand over Israel, this punctures that image. Hezbollah is going to have to somehow reset the clock on that without giving the Israelis a sufficient justification to go to take this conflict to a full war that Hezbollah doesn't want now, not because they've become pacifists, but because they're not prepared for it now. They don't have the full preparations. They're not in a place where Lebanon can handle the full brunt of an Israeli conflict right now. So they're going to have to thread their response between restoring their image, restoring deterrence vis-a-vis the Israelis, but also not giving the Israelis that justification that perhaps the Israelis are looking for to launch a broader campaign, because we're looking at these diplomatic solutions that are being offered to the Israelis. They're no solution for Israeli civilians who have been displaced from the north to return home. There's been increased signaling from the Israelis that only a military campaign can solve this problem, and they're tired of diplomacy. Hezbollah doesn't want to give them that justification to get the green light from either the United States or the international community.
I see. Yeah, we also are hearing that the IDF is declining to comment on the incident. The incident coming just hours after the Israeli cabinet added the return of citizens displaced from their homes in the north to the country's war goals. Axios also reporting Israel did not inform the Biden administration ahead of its intelligence operation that included these exploding pagers, thousands of them, of Hezbollah members' pagers devices here. So the preemption seems to be Israel's strategy, David, and how maybe you agree here. Remember, just weeks ago, they preempted that massive Hezbollah strike on targets in Israel. Israel with their own strike on military targets in southern Lebanon here. Hal, where does this go from here? Because remember, the ceasefire deal seems to be stalled with the hostages and Hamas. You sent something over that Joe Biden's national security advisors have no imminent plans to present the president with an updated proposal on ceasefire negotiations. That was reported in CNN. We're still waiting. We don't know whether or not this will come. The Iranian response to the targeted assassination of Hamas leader Ismail Haniyeh just a couple of months ago, and then this today. So where does this all go from here? How briefly, connect the dots.
Well, connect the dots real quick. It's preemption is one of Israel's mainstays, if you will. If you go back to the '67 war, that was preemption in terms of what they did to win that war. So that is something they do. What they're going to do is they're going to be testing to see what the reaction of Hezbollah is going to be. If Hezbollah does nothing, as David mentioned, this is embarrassing. And it's very difficult for Nasrallah and those around him to deal with that embarrassment. There's a political dimension to what's going on. The same thing is happening with Iran. This is embarrassing. Keep in mind, one of the targets or one of the individuals hit was the Iranian ambassador to Lebanon. That is embarrassing. And they're going to be watching to see what damage this does on the political level. And then I think they're going to be watching to see if certainly Hezbollah, but also Iran overreacts.
Okay.
And they want to be in a position where they are responding to something from a diplomatic political perspective. It's always better to say you're defending than to say you're doing something else, shall we say. And so they'll be looking to see if there's an overreaction there.
All right, David Daoud, Hal Kempfer, we're going to have to leave it at that. Can't thank you enough for coming on and helping us make sense of this really bizarre, stunning angle and element of the war. There are many unexpected elements to warfare. I think it's safe to say this one takes the cake. Thanks so much.
Thank you.
Thank you.
With the overseas in the Middle East, Secretary of State Antony Blinken landed in the region overnight in the aftermath of the deadly attack in Lebanon. Thousands of pagers belonging to members of Hezbollah exploded across the country. It was an Israeli operation. The region is now braced for response. Chief Global Affairs anchor Martha Radis is on the scene in Tel Aviv. Good morning, Martha.
Good morning, George. The death toll is rising this morning in Lebanon in this unprecedented, incredibly sophisticated attack. And this morning, Hezbollah vowing revenge against Israel. This morning, Hezbollah stunned and crippled by this brazen, highly coordinated attack. Thousands of wireless pagers, which Hezbollah uses to communicate and carry out its own attacks, simultaneously exploding across Lebanon. Operatives reportedly hearing a beeping sound, expecting a message, and instead the pagers blowing up in hands, in front of faces, and here you see in a grocery store. Photos circulating on social media appear to show the remains of a pager model used in the attack. Graphic images circulating online showing fingers blown off, bloodied faces, and damaged eyes. Bystanders rushing to help the injured, blood spilled in the streets, hospitals overwhelmed. At least 2,800 were wounded, many critically, close to a dozen. Killed, including a child, according to the Lebanese. Iran's ambassador to Lebanon
I muted my mic. My mic was muted. 1, 2, 3, 4, 5. Oh my god. Oh my god, what a disaster. Alright, let's tell him fixed. Mm-hmm. Very, very sad.
Officials in Lebanon say at least 12 people were killed, including 2 children, when pagers used by Hezbollah across the country exploded. Iran's ambassador to Lebanon is among the nearly 2,800 injured by these simultaneous blasts. Hezbollah militants began using the devices in the hopes of avoiding Israeli surveillance on their mobile phones. The militant group blames Israel for the explosions and says the attack will not go unpunished. There's been no immediate comment from the Israeli military.
Okay, so if you keep threatening and you keep getting killed, then everything is fine, you know? So what do you want? 1, 2, 3, okay.
Lebanon is in shock the day after what's been described as an unprecedented attack, as hundreds of pagers used by the militia group Hezbollah exploded over about an hour, causing several deaths and thousands of injuries. In the aftermath, many schools and shops are closed, and residents are still reeling.
What happened yesterday shocked us.
Look at what a beautiful place this is. Why do you want to ruin your own lives? You want to go back to complete destruction? You're on path to a complete destruction. How's my audio now? Let me check. 1. Yeah, my audio is much better now. So at least now we know we can mute. I wish I could stop the stream. How do you stop the stream? What's the command? There's a command to give it to stop the stream. I don't know how to do that. Anyway. What?
We began with the coordinator pager attacks, hundreds of pagers that blew up simultaneously across Lebanon. And that is further escalating regional tensions and have Hezbollah now vowing to retaliate. Lebanon's health minister says 12 people were killed, including children, on Tuesday, and nearly 3,000 were wounded, 300 of them critically. CNN has learned that the explosions targeting Hezbollah members were part of a joint operation between Israel's military and intelligence services. Innocent civilians were also killed. Now, the New York Times, meanwhile, is reporting that Israel planted the explosives next to the battery in each pager, as well as a detonation switch. Israel, though, so far is not commenting. CNN's Ben Wiedemann has more on this attack and fears that it could stoke a wider war.
Almost 200 people injured in the pager blast that occurred Tuesday afternoon were treated here at the American University of Beirut Medical Center, where the chief medical officer told us that even though there were women and children among the injured, the vast majority were young men. Now, thousands of people were injured in the apparently simultaneous pager blast that took place at about 3:30 in the afternoon Tuesday in areas where Hezbollah has a strong presence. Now, here outside the hospital, friends and relatives of those injured are waiting for news.
So I would recommend for anyone who doesn't want to be killed, doesn't want his children to be hurt and so forth, I would recommend to stop being an enemy of Israel. That's my recommendation. Just be friendly to Israel. That's going to make everyone better off. Just de-escalate.
Unsurprisingly, most do not want to appear on camera, but off camera, one told us, for instance, that a friend of his received a message on his pager. He picked it up, looked at it, and it exploded in his face, damaging his eyes and his fingers. Another individual who said he was a supporter of Hezbollah told us that despite these injuries, morale within the group is still high, and that those who were injured will soon return to the front. Now, Thursday.
Okay, then then don't complain when you die, when your children die. Like you're escalating. and you keep fighting. So what do you want the other side to do?
Afternoon, Hezbollah leader Hassan Nasrallah is expected to comment on the event.
Oh, this guy is a local Arab by his pronunciation. He's an Arab. I don't know if he's Christian. I think there's some Christians in Lebanon.
Of Tuesday, but on Wednesday morning, Hezbollah put out a statement saying there would be hard atonement awaiting the so-called criminal enemy that was behind what they described as Tuesd's massacre. I'm Ben Wiedemann, CNN, reporting from Beirut.
Well, it's a massacre of combatants, so it's fine. So it's not a massacre.
All right, let's talk more about this. CNN's Nick Payton-Walsh is in London, but first let's go to Paula Hancock, who's joining me now from Abu Dhabi. Paula, Israel is refusing to comment publicly on these explosions. What do you know about the purpose of this attack, the strategic goal?
Well, Amra, the goal that Israel would have and always has had is to debilitate its enemy, to make it impossible for Hezbollah to be able to fire missiles into northern Israel and to really cripple the organization. Now, what we've seen is that there are 2,800 injuries. We don't have a breakdown of how many of these are Hezbollah fighters versus how many are innocent civilians. What we do know is that at least 2 children are among the dead at this point. But what this has done is this has debilitated the ability of this militant group to be able to fight against Israel. We have heard that there's been some 460 operations so far from the health minister. The majority of those have been to the face.
Well, these people target civilians when they fire their rockets and their drones into civilian areas. So they target civilians. So the Israelis, don't target civilians, but sometimes civilians die in the process, even though Israel is not targeting civilians, it's obvious by the numbers.
And the eyes. So certainly critical injuries that are going to prevent militants from being able to fight in the near future. And of course, they've also taken out one of the very basic ways of communication between these large numbers of fighters. And what they've also done is instill a sense of paranoia amongst this group. Who can they trust? If Israel can get to them in this very significant and widespread way, then certainly there is going to be a concern in even trying to communicate any other.
But this means Israel was listening in to all the conversations. So Israel knows everything about them.
Members of the group. So Israel's intention was certainly to sow chaos within the group, which it appears has been managed. We understand that there was absolute chaos when this happened. We had the Ministry of Health calling health officials to come back to the hospitals because of the sheer number of casualties. Now, we also know that the US Secretary of State, Antony Blinken, is in the region. He has been in Cairo speaking with his counterpart. He just gave a press conference, and unsurprisingly, he was asked about this attack. Let's listen to his answer.
So with regard to Lebanon, the United States did not know about, nor was it involved in these incidents. And we're still gathering the information and gathering the facts. Broadly speaking, we've been very clear, and we remain very clear about the importance of all parties avoiding any steps that could further escalate the conflict that we're trying to resolve in Gaza, to see it spread to other fronts.
You can't just resolve. It's good that you're trying to de-escalate, but what are you doing? You need to go to the fundamentals. What is causing this conflict? You need to resolve the cause of the conflict. You need to talk about the cause of the conflict. The cause of the conflict is poverty. The Middle East is extremely poor, and poor people are extremely violent. We need to stop the poverty. How do we stop the poverty? We stop poverty the only way you ask an economist. The only answer an economist is going to give you is freedom, economic freedom. Just increase economic freedom in the area. That's all you need to do. As long as politicians are refusing to increase economic freedom, and Biden is not pro-economic freedom, Kamala is not pro-economic freedom, so you guys would never know how to solve this issue. You guys would only create such issues.
It's clearly not in the interest of anyone involved to see that happen. And that's why, again, it's imperative that all parties refrain from any actions that could escalate the conflict.
No, that's not true. When people are poor, it's win-lose. Like, if I can kill my enemy, I can take his stuff. So it's not in the interest of all parties to de-escalate when you're poor.
Back in Lebanon, we know that some hospitals are still operating at overcapacity, given the mass casualty event that this has become. We also know that others in the region are sending in medical supplies. Iran, Iraq.
It's a mass casualty of specifically militants. They're not saying that it's by far mostly militants. Anyway, waste of time. Let's see this. Wrong thing. I want to go to this video.
In this video, we shall solve the Schrödinger equation for an electron orbiting around a positive charged motionless proton, that of the problem of a hydrogen atom. We shall derive the explicit form of the electron wave function, or the so-called atomic orbitals, and will also visualize the shapes of these orbitals. We shall also obtain their discrete energy levels, and discuss how the transitions between these discrete levels give rise to the emission spectra as described by the Rydberg formula. Let's begin.
I mean, instead of solving this equation, I would just numerically run a simulation and see what it looks like. I don't really care to waste my time with mathematics if a computer can show me the answer. What's the point? What's the difference?
The potential energy of the electron, electrostatically bound to positively charged proton, is given by the Coulomb's law as shown. The energy scales inversely with their distance, r, and is negative because the force is attractive. Classically, we would expect that the electron would simply fall into the center of the proton. In quantum mechanics, this is not the case.
This is the voltage is a function of r. So this is not the force. Coulomb's law is a force law. It's not a voltage law. So it should be over r squared. I don't know why they say Coulomb's law.
The case, as we shall see in this video.
Where's Coulomb's constant?
We begin with the Schrodinger equation. We are interested with central potential, V, for which V is a function only of the distance from the origin.
Okay, so I've never seen this form of Schrodinger's equation. Del squared of what? Oh, of psi. Oh, this is in polar coordinates. So I've never developed this equation in polar coordinates. Okay, it's just a transformation of coordinates. Rotational symmetry, V r is a vector, is the same as VR is not a vector because of rotational symmetry. Okay, so this is the total energy times psi at r is psi at r. Okay, times the voltage at r and plus psi at, or minus psi at r, the del square. So I'm assuming del square means the curvature of psi, the second derivative of psi. This is time independent. There's no I. Interesting that there's no I in this equation.
Given by the radial coordinate r. The rotational symmetry of the hydrogen problem implies that the wave function would have a spherical harmonics part. Please refer to our previous video on discussion about spherical harmonics. We can express our wave function as function of the spherical coordinates, and the Laplacian in the Schrodinger equation is as shown.
This is too much. So psi at r is psi at r theta. No, he's skipping too many steps. He's not explaining enough. What's this?
The stability of the hydrogen atom cannot be explained by classical physics, and it is the search for an answer to this question that gives birth to quantum mechanics. In fact, classical physics would predict that the electron would collapse into the proton. Consider a neutral
Why?
hydrogen atom. The quantum mechanical solution to the hydrogen atom would entail an electron cloud distributed up to some finite radius from the center. Now, let's bring an ionized hydrogen atom to its vicinity. In other words, just a positively charged proton. We are interested in the following question. Will the electron cloud mediate the bonding of the two protons, or will the Coulomb repulsion between protons set them apart? Our goal is to address this question with quantum mechanics, or more precisely, the Schrodinger equation. If the electron indeed bonds the two protons, then the energy of the bound hydrogen molecule ion must be less than the energy of the hydrogen atom plus the energy of the free proton. Let's set up the problem.
This is basically H2.
And define R1 and R2 as the electron coordinate with respect to the first and second protons respectively. The two protons are a distance r apart from each other. We start with the electron Hamiltonian with a
Oh, we need to study Hamiltonian. So Lagrangian, I'm beginning to understand, but Hamiltonian, oh, notice that TFM is going live. Already has 5 people watching. He's going to get basically 500 people watching during his show. Okay. Yeah, we need to learn what a Hamiltonian is. All right. Maybe we're ready for a Hamiltonian. So, Hamiltonian operator, I guess. So I've seen this lecture multiple times. Let's just see what a Hamiltonian is.
In quantum mechanics, a Hamiltonian is a mathematical description of the total energy of a system, incorporating both kinetic and potential energy. The system
So a Hamiltonian is just the total energy, that's all?
being described could be anything: a molecule, a single qubit, or a bouncy ball. Hamiltonian can take different forms. It might incorporate different types of energy contributions, or be written in different coordinates or dimensions, which often makes them look very different. In quantum mechanics, knowing the Hamiltonian of your system is very important because it will allow you to solve the Schrödinger equation, the heart of quantum mechanics. The Schrödinger equation calculates how the system will evolve or change in time, which basically tells us everything useful we would want to know. That is why the first step of almost any problem or experiment boils down to calculating or identifying the Hamiltonian.
That's interesting. So the Hamiltonian is just the energy. So how does that make any sense? What just happened? So what did he say? He said Newtonian Lagrangian is not equal to a Hamiltonian. So he has a diagram: Newtonian, Lagrangian, Hamiltonian. There's some overlap, but it's 22 minutes. Let's see what he says.
If you study advanced mechanics, you probably think that the Newtonian, Lagrangian, and Hamiltonian mechanics.
Audio is terrible. I can't hear. Hamiltonian mechanics. What is Hamiltonian? All right, 7 minutes.
Welcome to Electroline. Now let's introduce ourselves to the Hamiltonian mechanics. What is Hamiltonian
So I saw one of his previous lectures. It was good.
mechanics? Well, let's run through it and see what we can figure out. First of all, the Hamiltonian is defined as the sum of all the x dots times p's minus L. What does that mean? Well, L is the Lagrangian, which is equal to the kinetic energy minus the potential energy of the system. And if we take a look at this, the summation of x times p, or x dot times p, notice that x dot is velocity and p is momentum. Since momentum can be written as mass times velocity, this can be written as mass times velocity squared. And mass times velocity squared is actually twice half mass times velocity squared, which means that mv squared is really twice the kinetic energy. Now, the summation sign here simply means all the components of the system. So if we like to compare that to the whole system, we can then say that this is really twice the kinetic energy.
Okay, this is very confusing. So the Hamiltonian is defined as the summation of xi dot, meaning all the velocities, times the momentum, I guess in that dimension, minus L, and the L, so this is all the, so P is basically mv, so this is mv squared. Oh, that's interesting. This is mv squared, but why is this P and this x dot? Interesting. And how do you derive it? Is he going to derive it? Advanced mechanics, Hamiltonian mechanics. What is Hamiltonian mechanics? So, but what is it?
Energy of the whole system minus the Lagrangian. Of all the x dots times p's minus L. What does that mean? Well, L is the Lagrangian, which is equal to the kinetic energy minus the potential energy.
So this is kinetic minus potential, but what's this? There's no 1/2 here, so it's not 1/2 mv squared, so it's not kinetic. I mean, it's mv squared. I don't know.
Of the system. And if we take a look at this, the summation of x times p, or x dot times p, notice that x dot is velocity and p is momentum. Since momentum can be written as mass times velocity, this can be written as mass times velocity squared. And mass times velocity squared is actually twice half mass times velocity squared, which means
So it's twice the kinetic energy.
that mv squared is really twice the kinetic energy. Now, the summation sign here simply means all the components of the system. So if we like to compare that to the whole system, we can then say that this is really twice the kinetic energy of the whole system minus the Lagrangian. The Lagrangian is the kinetic energy minus the potential energy.
Oh, look at that. So Lagrangian is kinetic minus potential, but you have two kinetic. So it's 2 kinetic minus 1 kinetic. So it's 1 kinetic minus 1 potential. So it's just the Lagrangian. Oh, it's the opposite of the Lagrangian. The Lagrangian is kinetic minus potential. So it's 2 kinetic, 1 minus 1 kinetic. Oh no, it's just a total potential. It's just 2 Ke minus 1 Ke. That's 1 Ke plus Pe. So it's just total energy. That's all it is. It's just the total energy.
If we subtract that from twice the kinetic energy, we finally have the definition of the Hamiltonian, which means the Hamiltonian is the sum of the kinetic energy plus the potential energy, which means it's the total energy of the system. Now, if we let the potential energy be some function of x, so we're going to try and figure out what we can do with this Hamiltonian. And let's say that function simply is c times x. So the potential energy increases.
I don't get it. Why are you telling me something so simple in such a convoluted way? I don't understand. I don't understand why you would do this to me. Okay, so now you're saying if potential energy is a function of x, all right, it changes about x, which is equal to CX. Okay, it's a constant times X. Okay, it's just a constant times X. So the potential energy somehow grows as X grows.
As a linear function of x, kind of like gaining height, for example. Then the Hamiltonian can be written as
Right, like MGH, assuming X is H. Then the Hamiltonian is 1/2 mv squared plus Cx. Well, that's the total energy, 1/2 mv squared plus Cx, yes.
It's 1/2 mv squared, which is the kinetic energy of the system, plus Cx, which is the potential energy of the system, the way we defined it.
Like, he should take a problem and solve it, not... that's not how I would teach it, so... Sorry. But before that, I need
Welcome to
to
electron line. Now let's
downvote.
introduce ourselves to the Hamiltonian mechanics.
Sorry. Let's start again. So I think this would be the best lecture.
Of course, just 1/2 mv squared, where v equals s dot is the speed of the particle.
My God, this guy's S's are penetrating my eardrums. Okay, the TFM show should have started. Okay, it's starting. I'm starving. We're gonna go eat tonight at 9 p.m. Oh, someone has joined. Hello, Mr. Spaghetti. Can you talk? Can you What's up? What's up? Again, you muted?
Hello, I'm fine, thank you. And you?
I'm terrific. So, what do you want to talk about?
Why is your name that?
Oh my God. It's for basically historical reasons, but that's what I was named by Alex. Alex Playing with Fire.
Oh, I know who is that.
He's like a big YouTuber, and I used to go on his show, and it was funny, and
That sounds super interesting. Okay, I'll be right back.
oh my God. This guy always disappears. Now I'm becoming a little bit hungry. Okay, let's see what TFM says.
You're like sore and you can't even lift any. Rheumatoid arthritis is not in remission. I'm better than I deserve. You know, my rheumatoid arthritis is not in remission. I'm having a good day. Like, my hands are really sore. That's the problem. Even when I have a good day and the inflammation is manageable, my wrists and the hands and shoulder are super sore, and I don't have full range of motion. I haven't picked up dumbbells in like over a month because I literally can't lift them because of my fucking baby strength. And even when the pain isn't bad, I just don't have the, like, it feels, you know, when you go to the gym and you like really kind of, you almost like go too hard and then you're like sore and you can't even lift anything for like a couple days because you tore your muscles. Yep. That's what I feel like all the time. So it's either that plus horrible crippling pain, or it's just that without the crippling pain because I'm having like a good day, which is fine. Like, I prefer the good days because I can sleep. Like, so it's actually really disgusting. Now, again, my rheumatologist appointment is in late October. It's as soon as they could fit me in. There are pills they can give me that will actually solve my problem, but only the rheumatologist can issue those pills. So right now I'm taking, what's it called? Meloxicam. Yeah. So I take meloxicam once a day. And then on bad days, I also have to take a leave with the meloxicam, which I say not to do, but it's like, okay, well, I have to because this is horrible. And then I also have to take this extended release arthritis pain Tylenol.
Oh my
and that's more
God.
for the soreness. So even if the inflammation is like, I'm scared to death, I'm going to like shake some boomer's hand, and they're going to do that shit where they squeeze your hands like a feat of strength, and I'm going to like wince like I'm going to wince like a girl, and they're going to be like, oh, what's wrong with this guy? It's like, I have rheumatoid arthritis, asshole. And they're going to be all proud of themselves, like, well, I'm a boomer and I'm like twice your age and I don't have rheumatoid arthritis. Like, yeah, I didn't like kick a gypsy and get like a gypsy curse put on me. I just have fucking rheumatoid arthritis. How about don't squeeze my hand like you're trying to break it off when my fucking hand doesn't work? Anyway, that hasn't happened yet. That's just like a fear. I'm worried like someone's going to make me, because you meet people, you want to shake their hand, and I'm going to have to be like, don't squeeze my hand, I have rheumatoid arthritis, and they're not going to listen because, they're boomers. They're going to be like, ah!
They're like, we destroyed the country, we might as well destroy your hand too.
Yeah. Oh, God. And here's the worst problem. I don't have a flight response. I have a fight response. I can't go to haunted houses because when people jump out at me, I punch them. I don't mean to. It's just that's my response. I have a fight response. So in fact, and that's the thing with my hands not working. Like, I'll do something and it'll really hurt. Like if I punch something or try to push something out of the way out of a reflex, it fucking hurts because my fingers are all sore. So it's not good. Having rheumatoid arthritis and having like a fight response is not a good combination. So yeah, anyway, that's what's going on. I'm doing all right. I'm sleeping better than I used to. I have to take a lot of pills, and I still got another month before I can actually see a rheumatologist and get like actual testing and an actual regimen. It's just frustrating. And what sucks is like, it's not like there's it's not like a mystery. They're going to run some more tests, figure out what type of rheumatoid arthritis I have, give me the appropriate pill, and then everything should clear up.
Okay, I don't care. We'll come back to him later. Let's go back to this guy.
Actually, I'd like to write everything in terms of theta. So I'm going to replace S dot with L times theta dot here to denote rates of change with respect to time. So if S of t is the position as a function of time, then S dot equals ds by dt is the velocity, and S double dot is the acceleration, the second derivative of S with respect to time. I want to write everything in terms of theta, though. The relation between them is just the definition of the angle theta in radians. Right now, before I get into the Lagrangian and Hamiltonian approaches. But I posted a whole other video just reviewing the basics of pendulums that I'll link below, so you can check that out if you want to see more of the details. And I'll also paste a link to some notes that I wrote about these topics, which you might also want to check out after you watch this video. First of all, we need to set up some coordinates to describe the position of the pendulum.
So he's going to solve the pendulum in three ways. One is the Newtonian, one is the Lagrangian, and one is the Hamiltonian. So this is the Newtonian.
We can use whatever coordinates we want, but it's simplest to use either the arc length coordinate s that runs along the circumference of the circle traced out by the particle, or we can use the angle that the rod makes with the vertical theta. They're totally equivalent, and either one will do the job for specifying the position of the mass. The relation between them is just the definition of the angle theta in radians. It's the arc length s divided by the radius L. We want to predict how the pendulum...
Okay, so S over L is basically, I think it's not exactly theta. Oh, the length of S over L might be exactly theta. The length of L. The length of the arc. The arc length, yeah. It could be that the arc length, that's exactly the definition of theta. Yeah, it's pretty much, that's the definition of theta.
The pendulum is going to move when you pull it up to some initial angle and let it go, or if you were to give it a little kick. According to Newton, we should start by writing down all the forces that are acting on the particle. There's only two of these, gravity mg pointing straight down, and the tension T in the rod pulling radially back toward the center of the circle. Then Newton tells us to add up all the forces and write F equals ma. The total force equals the mass times the acceleration. F equals ma is a vector equation, but what we're really interested in here is the tangential component, meaning the component of the force and the acceleration that point along the circle where the particle is constrained to move. The tension isn't contributing anything here. That's pointing straight toward the center of the circle, which is perpendicular to the tangent direction. So the only relevant force is actually the tangential component of gravity. With a little geometry work, you can see this is mg sine theta pointing back toward the pendulum's equilibrium position.
Okay, so he's saying this is mg. So this is, he says mg sine theta. Why is this theta? So this line is parallel to this line, and this line is parallel to this line. So this angle must be parallel to this angle, must be equivalent to this angle. Okay, so the next thing is that this to this is the sine of theta. So mg times the sine of theta is this. Mg times the sine of theta is this. What is, but what is he going to say about the arc length? Is he going to say something? Because it's supposed to be, oh, he's not going to want to do mg sine theta. For some reason, that's like too difficult. So usually we solve for mg theta because sine theta is equal to is very close to theta.
So F equals MA for the arc length coordinate S simply reads MS double dot equals minus MG sine.
So, MS double dot, very nice. MS double dot is equal to, wait, the total forces? The total forces is mg sine theta. It's not like MS double dot is MA. Anyway, it's the total force is mg sine theta. That's the only force we care about. Mg sine theta is equal to MS double dot, I guess.
Sine theta. I'm using dots here to denote rates of change with respect to time. So if S of t is the position as a function of time, then S dot equals ds by dt is the velocity, and S double dot is the acceleration, the second derivative of S with respect to time. I want to write everything in terms of theta though, so I'm going to use the fact that S double dot is equal to L times theta double dot in order to rewrite the F equals MA equation as theta double.
He wants, so he's using S and theta, and he wants to switch to, I guess, to theta. So he's saying that theta is defined as S over L, which means S double dot is L theta double dot. We'll put a dot on both or a double dot on both, that's fine. So, well, M drops out. I don't think he mentioned it, but then we're left with S double dot, which is theta double dot. S double dot, no, it's L theta double dot. It's not theta double dot. S double dot is L theta double dot. Where did the L go? And G stays. And let's see what happens to sine theta.
Double dot equals minus G over L sine theta.
Oh, he brought the L over to here. He's skipping steps. And sine theta, okay.
This is called the equation of motion for theta. It's the differential equation.
This is the differential equation. Theta double dot is equal to negative G over L sine theta. This is pretty straightforward, isn't it? Like, sine theta, if you take a derivative, it's cosine theta. Take another derivative, it's sine theta. So all you need to figure out is something, I don't know.
Equation that governs the motion of the pendulum. And it's actually pretty complicated in this case because of this factor of sine theta on the right-hand side. Too complicated, in fact, for us to be able to write down a simple solution in general. There is one special case when we can, though, and that's when theta is small, meaning that the pendulum never gets very far away from its
Why is it so difficult? I don't get it.
equilibrium position. In that case, the solution is just a sine or cosine. If you want to know how that works, check out the other video that I posted all about pendulums that I've linked down below. Here's a little animation that I made to show you what this looks like. I'll paste a link below so you can go play with it too. You drag these little sliders here to set the initial angle and initial angular speed of the pendulum.
No, you just said theta must be very small, and now you're increasing theta to very large, so it shouldn't hold.
And then press start to let it go and see the resulting motion. When I release it from a small angle like this, you can see that theta versus t.
Oh, he's going to mention that when theta is big, it doesn't look realistic, I think.
Indeed looks like a cosine function. So I hope you'll go play with this. Try choosing different values for the initial conditions by dragging the sliders. Draw for yourself what you think the graph of theta versus t should look like with those initial conditions, and then press start to see if you got it right. All right, so that's a quick review of how we understand the motion of the pendulum using Newtonian mechanics and F equals ma. But there's a lot more.
1 second, let me just check my audio.
Theta versus t should look like with those initial conditions, and then press start to see if you got it right. All right, so that's a quick review of how we understand the motion of the pendulum using Newtonian mechanics and F equals ma. But there's a lot more.
1 second, let me just check my audio. Audio is good. Let's get back to TFM.
But I just have to go to the rheumatologist to do it. Like, they can't do it over the phone. They can't squeeze me in early. My primary care physician can't take care of it. The teledoc can't take care of it. Like, everything is compartmentalized. Like, even if the doctor knows what the problem is and knows what the solution is, they can't help you because they don't have the proper credentials. You have to go to this doctor, and this doctor has like a 2-month waiting period and costs like fucking $500 to see just to get a prescription. It's so frustrating.
And the funny thing is, they don't even do anything for it. You walk in, they ask you a few questions, and then they go, "Oh, you need X." And that's exactly what you were there for. And then they literally just punch a couple keys until you'll see you again in 6 months.
Yep. And the sucky thing is, so again, I was using because I have a really strong immune system, which is kind of the problem. And I don't go to the doctor. I haven't been to the doctor in like probably 10 years. I don't think I've been to the doctor since I left the military, and that was like 2010. So it's been 14 years since I've been to the doctor. And if I need a prescription, I just use a teledoc. You basically, they call you, you talk to them, they send a prescription to your pharmacy, you pick it up, you're done. It costs $15. $15 for the appointment, whatever the prescription drug costs, easy peasy, in and out. Suddenly I needed a primary care physician. Like, they wouldn't help me. They wouldn't give me like long-term stuff or the arthritis pain. So I had to get a primary care physician. I had to wait a month for that. And that was a $250 copay just to go to an appointment, talk to them for 5 minutes, have them give me the meloxicam. That was $250. And now I don't even know what this fucking rheumatologist is going to cost. But it's functionally...
It's basically theft. The way it works in America, it's theft. So the American Medical Association, AMA or something, which is what do you call it? It's a cartel. It's a government cartel of doctors. It doesn't make any sense. Why is there an American Medical Association? Why is there only one of them? Why aren't there multiple American medical associations competing with each other? I mean, if you want government to be involved, that's fine, but there shouldn't be just one. That's called a cartel. It's a private, the American Medical Association is a private organization, just like the banking system. Why is there one banking system? What if I want to create a competing banking system? The Fed is a private banking system that is sanctioned by the government. This somebody has to sue the government that this is illegal. This is unconstitutional. It must be violating something. And anyway,
identical to the teledoc. You're just talking to a guy. He's giving you a prescription, and you're in and out. I have a problem. This is the problem. Insurance will cover. Can we get this show on the road?
And it's just going to get worse.
Well, it's designed to be inefficient in order to create. Because basically, it's like the proverb. I think it was Milton Friedman. He talked about like the Soviet Union. They were digging trenches or digging like.
Yes, yeah, it's by design. This is theft.
Digging a road with shovels, and he was like, "Hey, why don't you use like equipment? Like a backhoe or a bulldozer? Why are you digging with shovels?" And they're like, "Oh, well, we're creating jobs." Like, "Oh, I thought you were like making a road. I didn't think you were creating jobs. Take your shovels away and give them spoons." And that's what they've done. That's what they've done in the medical establishment. They've artificially made it more complex. They've artificially inserted a whole bunch of middlemen in order to create jobs. So there's
that, and also they keep adding more mandates to insurance to favor
yes.
really politically like necessary groups like illegals and crannies and people like that. Or they do like, oh, we now mandate that insulin only costs $35. So every time they do that, the insurance companies have to re-rig everything so that everything else is more expensive to cover the shit that there is. That's why if you go to a doctor and let's say they bill your insurance company like $150 for the appointment, if you say no, I'd rather pay cash, they'll charge you $100. But that's what it's supposed to cost. It's just that they charge the insurance company $150 because the insurance company makes it more difficult and they have different reimbursement rates for different things.
Yes, the expenses are one thing. Money is the one thing I have. It's the waiting a month and a fucking half to talk to someone to get a prescription that could be a phone call. Like, this is shit that should take 5 minutes over the phone, and I have to wait a month and a half and pay fucking whatever.
There's not enough doctors in America in order for doctors to be expensive. This is supply and demand. So the American Medical Association reduces the number of medical schools artificially, reducing the number of doctors that graduate every year artificially, reducing the supply of doctors artificially, increasing the price of doctors artificially. This is government mandated. This is basically price control. This just raises the price of doctors. I mean, there's no reason why a doctor should make any more than anyone else. And there's no reason it should take so many years to train a doctor compared to any other profession.
That's what pisses me off. Like, the money's fine. What the fuck? Hold on. Every fucking week I tell them, don't add me to events on Wednesday. And every fucking week they do. So give me a second. Let me go to my upcoming alarms and turn them off preemptively. Okay. All right. Condition that's really expensive. And they'll make it mandatory for all. Organized minority will always overcome the disorganized majority. So you have a...
Like, think about this. Every single man has to pay to cover pregnancies, even if they're not married.
So, like, if people who had kids had to pay the full cost of public education, they would just go to private school because it's so expensive. It's only cheaper because everybody's paying it.
Yeah, but one can at least make the argument that having a good school system will raise property values.
But you could have a good school system that's private. I mean, they used to have the Little Red Schoolhouses where the local parents would hire a schoolmaster to teach their kids out of their own pocket.
All my kids are private. You're preaching to the choir. But I'm just saying that's the argument they make.
Right. When it comes to medical stuff, it's usually like just certain politically advantaged groups that want coverage for niche conditions that are really expensive. So they basically make everyone pay.
TFM used to talk economics, but lately he has been becoming a communist. He is slowly becoming a communist. Today, he's still a capitalist.
For it to make it cheaper for them to pay for it. Again, the cost is one thing. Healthcare is expensive. I knew that going in. The wait times. And the thing that pisses me off is I can understand this was like, some socialized medicine system or Canada where it takes like 6 months to see a doctor. But we have Teladoc. where it takes fucking like less than 30 minutes. I can make it, I put me on teledoc and get a phone call in like 10 minutes, talk to a doctor, get my prescription, rheumatologist. And it doesn't just fucking call me. If I need blood work, there's like LabCorp and there's other. That's the, so if you need my blood drawn, stool sample, whatever, I could do that. There's like all these LabCorp buildings and places like that where you can do the labs. I'll send you my labs, I'll do whatever. But this can all be done over the phone. There's no reason for me to wait a month and a half to go to an appointment to just sit in an office with you. Specialist, talk to me in 15 minutes. Why do I have to wait a fucking month and a half to fucking send a prescription to a pharmacy? Cool. I think $50 for a phone call is adequate compensation for a medical specialist. We're talking 15 minutes. We're not talking an hour. That's pretty good. That's $100 an hour, or over $100 an hour. Say 15 minutes. That's $200 an hour. That's pretty good for a doctor. So why for a phone call? Like you call 4 people an hour, 15-minute phone calls. You make $200. That's pretty good. But it's no. You gotta go to the point. You gotta go to the thing. And it's like this boomer shit. We have to justify, and all it is to justify. Have that. This can be a phone call. We don't need to have a call it a fucking day. Like we have programs. That's what pisses me off. It's the, in my opinion. Because everyone wants to work for like the government or the health service. Like these are good paying jobs. But in order to justify job growth, and the government is notorious for this, they just like make things shittier, make things less efficient, more shittier, more bloated, so they can create more jobs, increase the budgets, and get more, because everyone loves working for the government. It's great. Good pay, good job benefits, good job security. It's just bad for everyone who has to interact with the government.
So I saw something recently that said like the vast majority of the job growth under Biden has been from government.
No, it's been, we've been losing, American jobs have been lost, but they've been made up for by illegal aliens being to pick strawberries. That's a wash. The strawberry picking job is just as important to the economy as the middle class 6-figure job that the domestic American worker lost. They're cooking the cover up their profligate spending and their shitty monetary policy and try to like forestall the economic apocalypse through bullshit and lying and whatever. This has all been done before, and it's old.
I mean, I don't know if he keeps predicting an economic apocalypse, but I think that there's no indication there's an apocalypse coming.
Always fail. The laws of economics always win. So we're kind of coming into the end game at this point. The fact of
Yeah. But the economy is very stable. You have to compare the U.S. economy to the rest of the planet. The U.S. economy is by far more stable. The rest of the world is becoming destabilized as the U.S. is still very stable.
The Fed's going to cut rates today. My prediction is 25 basis points. Now, there's a rumor they're going to cut 50 basis points. And I'm like, that doesn't make any sense because there's nothing in the economy. Like, well, you know what? Before we get into this, let me shout out the sponsors and then we'll circle back. All right, the Dollhouse. Want your own Tifa doll or Aerith or Lara purveyor of a very she felt the love nestle torso because he wrapped around skin feels like you're fucking an actual one solid skin. Skin looks real, twice as much as the product, much more real outcome. And now it's only make torsos. So because the problem, you don't want to have to get her in position, move her clothes.
Okay, let's get back to Lagrangian. So this is Newtonian. So he says this is too difficult to solve. All right.
Quantum mechanics and ethical MA. In the years after Newton's work in the late 1600s, new approaches to mechanics were developed by Joseph Louis Lagrange in the late 1700s and by William Rowan Hamilton in the 1800s. Lagrange and Hamilton's approaches offer new practical and theoretical insights into the structure of mechanics, and they're especially relevant in the study of quantum mechanics, meaning the physics of very small objects like atoms and elementary particles, as opposed to the classical mechanics that Newton, Lagrange, and Hamilton originally studied. Now, I should say that the Lagrangian and Hamiltonian approaches to mechanics are a little bit more mathematically sophisticated than Newton's approach. So depending on how much math you've already learned, they might seem like they're a little bit more challenging. But they're both really fascinating, and they provide new insights and strategies for solving problems. Remember that it's also totally fine if you don't follow every single detail that I present here. What I'm really hoping is that you'll be inspired to go off and keep learning more on your own. All right, let's look at the Lagrangian formalism next. Whereas Newton told us to start by writing down the total force, Lagrange tells us to start by writing down the kinetic energy, the potential energy, and then taking their difference. This defines a function called the Lagrangian L. Let's see what the Lagrangian is for our pendulum example. The kinetic energy K is of course just 1/2 mv squared, where v equals s dot is the speed of the particle. Actually, I'd like to write everything in terms of theta, so I'm going to replace s dot with L times theta dot. Then the kinetic energy is 1/2 m L squared theta dot squared.
Okay, so the kinetic energy is 1/2 mv squared. In this case, it's 1/2 m s dot squared, which is 1/2 m L squared dot theta dot squared.
The potential energy U, meanwhile, is just mg times y, the height of the particle above some
Yeah, it's just mgy. Okay.
chosen ground level. I'm going to put ground level at the height of the pivot. Then the y coordinate of the particle is minus L cosine theta, and the
So this is y equals 0. So originally it's this is y equals L. So originally it's mgl, and I don't know what he's going to say. And it goes up and down relative to theta such that the y equals L cosine theta.
potential energy is minus mg L cosine theta.
So this is y. I guess maybe y is pointing down. I don't know. And y This is positive y. Positive y. So y could be here. Y is going to go up and down. So y is L cosine theta. This is y. This is positive y. But we want the potential energy as y goes down. We want the potential energy to go down. So when y is positive, the potential energy is negative. Yeah, that makes sense. What's going on? It's fine.
So the Lagrangian for our pendulum is the difference between the kinetic energy and potential energy. That's 1/2 ml squared theta dot squared plus mgl cosine theta.
Okay. Cosine theta. All right. So the Lagrangian is k minus u. K we already said is 1/2 ml squared theta dot squared. That's fine. And u is negative mgl cosine theta, which is positive mgl cosine theta. All right. So that is the Lagrangian.
So Newton told us to start by writing the total force and setting it equal to ma. Lagrange instead tells us to start by writing the Lagrangian like we have here, and then using it to write what's called the Euler-Lagrange equation. That's d by dt of dl by d theta dot.
Okay. Very good. So he's skipping all the steps, and he says, wait, I have an email. Yeah. I hate it that I look at my phone and it's like, it's not telling me that it's not going to show me anything. Now I need to unlock my phone. So what was the email? Let me see the email. It's fine. It's fine. What's this? Everything is fine. It's good. It's good. Everything's good. So this is the Lagrangian. And the next step is to write the Euler. He said the Euler-Lagrange equation.
By writing the Lagrangian like we have here, and then using it to write what's called the Euler-Lagrange equation. That's d by dt of dl.
We'll come back to the Euler-Lagrange. Yeah, okay, let's go to the Euler-Lagrange.
By d theta dot equals dl by d theta. By the way, the curly d's here stand for partial derivatives. If you've never seen those before, don't worry about it. For practical purposes, they behave just like
You
ordinary.
want to tell me that you're expecting people who've never seen partial derivatives to follow this lecture? I mean, what? I would, like, how? I can barely follow it, and I'm basically, I can teach partial derivatives. Jesus. Anyway, so he says this is the Euler-Lagrange. So here is L, and we're going to do the partial dl d theta dot partial dl d theta. Very interesting. We have theta dot and theta. And we're going to do it, and then we're going to do a derivative with respect to time. Okay, let's do it.
Derivatives. Now, I'm not going to get into too much motivation as to where this Euler-Lagrange equation comes.
1 second. Let's go hear what TFM says. So I don't get it. I mean, he keeps saying we're in recession, we're in stagflation, but now he says there is no indication of a recession. He's just being inconsistent. the Fed shouldn't exist. The Fed this is not only a waste of money, but it's a form of destabilization to the economy. Why should a bunch of people decide something so significant like the interest rates? Why? Let the market decide what the interest rates should be. Like the market decides the price of anything. Interest rate is basically the price of money, the price of credit, the price of borrowing. Why should it be different than any other commodity? Like the government doesn't decide the price of cucumbers. Why should the price of borrowing be any different? How is it? I mean, it's not even the government. It's a private bank that is what do you call it? Like it's a cartel that is anyway protected by the government by law. The interest on the debt. Oh my God. I don't think anybody's being forced to do anything. Okay, we have a visitor. Mr. Spaghetti, how are you?
Hello, I'm fine, thank you, and you?
Okay, what do you want to talk about?
I don't know, what do you want to talk about?
What do I want to talk about? I mean, right now I'm deep into physics, quantum physics, mostly quantum physics, maybe a little bit of general relativity. I'm still making up. That's it. And my
Okay, cool.
yeah, like what do you like?
Yeah, those are cool. I like them.
What? Those are what?
Yeah, I like quantum physics and general relativity. Those are cool.
Do you know anything about quantum physics?
Yeah.
What do you know about quantum physics? I mean, you don't have to know. I mean, I'm just, you said you like it.
Weird. I know that it's weird.
Well, what does that even mean? What do you mean it's weird? How do you know that it's weird?
Why
do you
violates local realism or something?
What do you mean? Can you prove it?
Yeah, violates local realism.
What does that mean?
It means it's not locally real.
Oh, so you're an expert.
What?
I'm saying so you're an expert. Why do you keep muting yourself? And it takes you such a like there's a delay every time I ask you a question. There's like a long delay, a pause.
No. No.
Wait, so quantum mechanics. So like, what's your proof that it's what does it mean that it's locally? It violates whatever local realism. Well, what's your definition of violating local realism? How do you define that?
Yeah, no, it's
Yeah.
not locally real. Local realism is false.
Wait, I can barely understand what you're saying. Can you explain your position?
Yeah.
Go ahead.
things don't have properties.
What do you mean things don't have properties?
Yeah, like things like electrons don't have properties like spin or something. I don't know.
I mean, okay. What I mean, what do you mean? What do you mean electrons don't? So electrons do not spin? Is that what you're saying?
Yeah, it's not real.
What do you mean it's not real?
It's not real.
What do you mean? I mean, what's your
It's
definition?
not, because you can observe it, but it's not real when you're not observing it.
So not real means it's not when you're not observing it, it doesn't exist.
Yeah, it don't exist. It doesn't have that. It doesn't exist.
What's your evidence for that?
Electrons.
Yeah, electrons. Yeah. Why do you keep disappearing? I can't hear you.
I don't have any evidence, but anyone Stern and Gerlach have evidence, so ask them.
Yeah. Tell me about that. Let's talk about that.
They did some experiment with atoms and magnets.
Okay. And
they
do you want to talk about it?
Yeah, I'm talking about it right now.
No, but do you want to talk about it? Like I don't like, or do you?
Not really.
Oh, okay. So what
Why
do
don't
you?
you tell me about it?
What?
What have you learned about it?
What have I learned about it?
Yeah.
I honestly, I mean, the only violation that I know of realism or whatever is the spin. But I don't need to say that spin violates realism because I don't understand spin. See, it's I don't understand spin. I've never heard anyone explain spin. Everyone I've listened to explaining spin says they can't explain spin. And then they use spin to prove there is no realism. So I'm confused. It's like you said.
Take a wheel and rotate it. That's spin.
Okay. Does an electron spin?
Yeah.
So an electron spins?
Except sort of, except not really.
So there you go. So you see, it's not clear what it's not clear that electrons spin. Do they spin? Do they not spin?
Well, they have a magnetic moment, so,
Mm-hmm.
So they must have spin.
Can you explain to me what an electron is?
Yeah, it's a little ball that's charged, electrically charged, and it's also spinning, so it's like a little magnet.
What do you mean it's so? Wait a minute. So if it's a little ball that is spinning, so it's a little ball that is spinning, physically spinning?
Yes, sort of. I don't know.
Right. So it's not clear that it's whatever you say it is. It's just not clear. So you say, I don't know what an electron spinning is, but now that I admitted I don't know what a spinning electron is, let me prove to you there is no realism. That doesn't make any sense. You can't, once you say you don't understand something, what's the point of continuing to talk about it? I mean, obviously, if you don't understand something and you continue talking about it, you're just going to exacerbate not understanding anything that comes out of not understanding.
Well, you can measure the magnetic moment with magnetic field.
So, okay, but can you explain to me what an electron? So you said an electron is a ball that is spinning, and then you said sort of, not really, or something. So
Yeah, it's sort of like this.
What do you mean sort of? Sort of means not really. Sort of means not. It's not.
Yeah.
So what is it? I need to know exactly what it is. I need a concrete explanation of
Okay,
what.
it's a little arrow.
That doesn't make any sense. Is it spinning? Is this? You said before. It's
No,
a,
it's just pointing in a certain direction. Except sort of, not really.
Okay, so you keep saying sort of, not really. So if you're going to base your proof of violation of realism on something you don't understand, then I'm just going to claim that the proof is invalid.
Okay, so maybe the proof is invalid. Okay, what else have you learned about?
No, this is extremely deep. I mean, the Nobel Prize was awarded for whatever, proving Bell's theorem. So it's complete nonsense. Bell's theorem is complete nonsense because it deals with spin. It's not that it says something about something that we do understand. He literally takes something that we don't understand. He says, okay, now that we don't understand something, let's build on top of that thing we don't understand and prove we don't.
But it can be measured. You can measure the magnetic moment.
Explain to me spin. Explain to me what spin is.
Yeah, it's a property.
Yeah. Can you?
It's a property that can be measured in.
How did you measure it?
Be measured in units of angular momentum.
Fine, but what's the apparatus? What was the experiment where you measured spin?
Well, I didn't do the experiment. Stern and Gerlach did.
That's fine. So that was the experiment where they actually measured spin?
All measurements are indirect. You're not. When you measure the height of a refrigerator, you're just putting a ruler next to it. You're not measuring the height directly. You're just comparing 2 points on the refrigerator to 2 marks on the ruler.
Okay.
So you're not really measuring the height of the refrigerator.
Okay. And when it comes to an electron?
They showed that that they were deflected by a magnetic field in a way consistent with having a certain spin.
What is spin?
Angular momentum.
Spin is angular momentum. So how does
Yes.
Okay, so you said before an electron is a tiny ball. Do you still?
Yeah, it's an electrically charged little ball.
Okay, it's an electrically charged little ball that is spinning.
Yes.
Okay, so it's a
Sort of.
Excuse me.
Sort of.
What do you mean, sort of? What is it exactly? Why do you say sort of? What is not? What is it about an electron that is not as you say that it is? And why do you hedge your definition with the sort of clause? What do you mean
You
sort
should ask a physicist because I'm not a physicist. I'm just a guy.
So are you retracting everything you said?
No.
Do you stand
I'm
behind?
just explaining why I can't. Why I don't know exactly what an electron is.
Do you know? Okay. Do you know? Is there anything else about the universe you don't know exactly what it is?
Yes.
Like what?
Frogs. I don't know exactly what a frog is.
Really? What don't you know about a frog?
Well, apparently there's a difference between frogs and toads, but I don't know exactly what the difference is.
Well, okay. But I don't think that there is a
like toads live in drier environments, but I guess maybe, and they have bumpy skin, except that's not that's not universal, so I don't know exactly what the difference is between a toad and a frog.
Mm-hmm. But in general, we look at a frog and we can, study it. We have a good understanding of a frog. We can, right?
You have a good understanding of a frog. If I gave you an animal and asked you, is this a frog or a toad, would you get it right every time?
I would say that's not an interesting question. The interesting question is, does anything else in the universe violate reality or something like that? Is there anything else about the universe that you've studied that you can't?
Other than electrons, other than spin?
Yeah, it seems like spin.
Well, technically, every property does.
Like what?
Technically, every measurable, every observable property does, but it's
like what?
It's just easier to measure in the case of an electron spin.
What besides spin is confusing?
Everything.
Namely?
For example, momentum.
What about it?
Yeah, it also works the same way.
What do you mean? It violates realism, reality, whatever?
Yeah.
How?
Anyway, do you think quantum computing is real?
No.
Why not?
Because there's no superposition.
There's no superposition. Why not?
Because Schrodinger's cat thought experiment proves it. Do you think the cat?
How does it prove it?
Because do you think the cat is both dead and alive until you open the box and look?
Well, that doesn't prove it. It's just counterintuitive, but doesn't prove that it doesn't exist.
Wait, well, you tell me. Do you think the cat is both dead and alive until you open the box, and then it suddenly collapses into one of the two states?
Yes.
Really?
Except maybe not. There are other ways to resolve it. There are objective collapse theories.
Wait, what do you think? Do you think the cat is both dead and alive?
Maybe.
Maybe?
That's what.
Let me ask you, what if it's a
That is.
person? Wait, what if it's me in the box?
Yeah. Then you'll be both dead and alive.
Am I both dead and alive? Until
Yes.
you look? So
Yes.
1 second. Okay. So you are right now not looking at me. Am I this instant both dead and alive? Because
No, because I'm observing you right now.
you're not right now.
I'm interacting with you.
Well, not right now.
I'm entangled. I'm entangled with you. My state is entangled with your
Well,
state.
not right now, right?
Yes, it is. My state is entangled with your state right now.
No, during the pause,
As
as
I'm
I'm
listening to your voice.
no, but as I'm pausing, in that instant, there's no interaction. At that instant, you would say I'm both dead and alive.
Oh no, there's still interaction. There's still background noise being picked up by your microphone.
Yeah, but I
and
might
that's
be.
enough.
Yeah, but
cause-
I might be dead. According to you, I'm dead and alive.
That's enough.
What do you mean?
You're in a very noisy environment.
I am?
So your state's entangled with everything around you. You need to go inside a box made of solid lead and seal yourself inside it.
I mean, the distance between us. So I'm gonna do push to talk. If I
No, the distance between us is not that large.
Look, obviously it doesn't make any sense. It's complete. It's. There's no evidence for this. It's complete nonsense. There's no superposition. It doesn't make any sense. It doesn't look. I don't even need to use Schrodinger's cat. Superposition makes no sense. It is literally senseless. To be both dead and alive is literally senseless. For a quantum particle or any particle to be both something and its opposite is literally senseless. It is literal senseless. It literally makes no sense. Literally. I'm not even saying figuratively.
Well, it is highly counterintuitive.
No. So yes, highly counterintuitive is literally senseless. That is the definition of senseless. It's nonsense. It is definitionally nonsense. So to tell me that, look, you can tell me I don't understand this phenomena, but you cannot tell me.
So what's your alternative to quantum mechanics?
Here.
Is it something like Bohm's pilot wave theory?
Here, look. You cannot tell me I don't understand something. Now that I discovered I don't understand something, let me build on this lack of knowledge and spend trillions of dollars on research to build on this lack of knowledge. That is nonsense to the nth degree. It's nonsense on nonsense. Of course there's no quantum computing. Of course it doesn't exist. It's nonsense. It's literal nonsense. It's not even figurative nonsense. It's literal nonsense.
Okay. What about general relativity? Do you think that's nonsense too?
No, it's just incorrectly interpreted. Einstein.
So what's this?
There's no curvature of space-time. It's just the flow. It's a flux of ether.
Okay, so I think that's basically what's his name? Lorentz believed. Actually, I'm not sure if it's consistent with general relativity, but it is consistent with special relativity.
It's consistent with both. I'm 100% consistent with both special, general relativity, and quantum physics. I'm completely consistent.
So why can't space-time be curved?
Because that makes no sense. Something that makes no sense.
Makes a lot of sense.
No, it makes no sense. It just makes no. I don't know what that means. Here, let me ask you a question. Why does the apple fall from the tree?
Because demons are carrying it down.
Well, that actually makes more sense than the interpretation of Einstein's interpretation of his own GR. By the way, he said he doesn't understand it. multiple times. So a guy that doesn't understand something interprets it, and everyone quotes him. So very unfortunate. Look, I agree with the math. I just disagree with the interpretation. That's all. The interpretation is obviously is that ether flows through the apple into the ground. And that is what's causing the apple to accelerate towards the ground, right? Your answer.
Alright, but how do you explain? Okay. So can the topology of the universe change?
Can the topology of the universe change?
Yes.
What is the
So like
what is the topology? The universe is
like
filled.
sort of the global shape, like we typically imagine the universe as an infinite, sort of flat hyperplane.
I don't know what
But
flat means. Are you asking?
Flat means not curved.
So in general, there is no flow of ether. There's no such thing as curved anything. Nothing is curved. That doesn't make any sense. Once you understand how an apple accelerates towards the ground due to gravity, then you'll understand that curvature is a misinterpretation of GR. And the correct interpretation is the flow of ether. So instead of telling me, instead of joking, when I ask you why does an apple accelerate towards the ground, instead of joking and saying it's a demon, try and think about it. The only explanation is, that ether is a fluid that fills the universe and is flowing into massive bodies and drags.
Yes.
Excuse me?
Yes.
So what's the question?
Well, the real explanation is that the apple doesn't fall. The ground is just accelerating upwards.
What do you mean it's just accelerating upwards?
The ground is accelerating upwards.
No, that's not GR. That's not GR, and that doesn't make any sense, and that doesn't fit our observations. That's a nonsensical statement.
No, it's not.
Yes.
Okay, so imagine a disk inside a sphere, inside a spherical surface. And now if you take two lines in the sphere, so two geodesics in the sphere are great circles, and if you follow them, they will converge until they intersect. Now, if you take a disk embedded in the sphere and it's moving through the sphere, if each point is following a straight line, the points will converge and the sphere will, or the disk will shrink.
You have a
So in
video.
order to see the sphere,
You have a video of this?
Not right now. But
I mean,
I'd find one.
Okay. So look, so an apple, obviously we observe an apple falling towards the ground. Right now I feel pressure on my tushy. Right? So there's obviously a force. What is that force? Where is that force coming from? Explain to me the force. Something is dragging me. Something is dragging.
Floor accelerating upwards.
The floor is accelerating upwards?
Yes.
How? The Earth is of a constant size.
Yes, and that's why it requires curvature to explain.
Look, in order for the floor to accelerate upwards, we need the Earth to expand, to accelerate.
No. The Earth just needs to not shrink. If every point on the Earth was following a geodesic, a straight line through space-time, then the Earth would shrink. But it's not.
Okay. I don't understand what you're saying. I don't see any evidence to what you're saying. There's no evidence. There's no evidence the ground is moving.
Okay, so take a
No.
rigid
I'm not going to take
a
anything.
rigid
I'm not.
segment of a
I'm not.
great
I'm
circular
looking.
arc.
No, I'm looking at Earth from space. It's solid. It's not expanding. I'm not moving up. Relative to what am I moving up?
No, you're not moving. Well, no, relative to the center of the Earth, yes, you're accelerating upwards.
Relative to the center of the Earth, I'm accelerating upwards?
Yes.
How can you say this? When I look at the moon, it's not growing. I look at the sun, it's not growing. According to you,
Yeah, they don't have to grow.
then I don't then we don't define the words similarly. We have different definitions of words. I just don't understand what you're saying.
Like I said, it requires curvature to explain, but you reject curvatures, so.
I don't reject
Fine.
anything. I reject the interpretation of GR as curvature because it doesn't explain why the apple falls. Why does the apple fall?
The apple does not fall. The ground just accelerates up towards it.
Look, I measure, according to me, in my frame of reference, the apple accelerates towards the ground. I'm accelerating towards the ground.
Now that's because you're accelerating upwards because you're standing on the ground and it's pushing you
But
up.
I'm not, but there's no indication that I'm moving. The indication is the apple is moving. By all measurements.
Yes, that's because by definition, in your frame of reference,
Wha-
you're standing still.
Okay, why don't you? Okay, let me ask you. You're giving me an explanation that I simply that does not conform to any experience I have. I'm giving you an explanation that conforms to every experience I have. So according to Occam's razor, you should reject your explanation. I'm not saying the interpretation of curvature is incorrect. The interpretation of Earth-centric model is not incorrect. It's not more correct or incorrect relative to the sun-centric model. It's just that the Earth-centric was more difficult than the sun-centric. The sun-centric is just a simpler model. That's all it is. I can explain everything.
Right. Well, you can use the Newton's explanation to make the same prediction. So there's this mysterious force.
Look, the sun-centric model is not more correct than the Earth-centric model. The curvature explanation and the explanation you're giving me that I'm accelerating upwards is not more or less correct than the explanation that I'm giving with the ether. They're all the same. The ether is in GR. It's in SR. It's there. It's in quantum field theory. It's there. The ether is there. It's just an interpretation. So your interpretation is, as you say, counterintuitive. My interpretation is more intuitive. It's just a better, simpler, more scientific explanation. That's all. Your interpretation makes amazing predictions. Mine is the same, gives the same predictions. I'm using the exact same math. I'm just interpreting it to be simpler. That's all. Just everything is intuitive in my universe. I'm not rejecting anything from modern physics.
Okay, well, I think the curvature explanation is more intuitive.
Why? Did you hear my explanation?
Yeah, there's invisible ether that's flowing around.
No, I didn't say it's flowing around. It's flowing towards the Earth. It's flowing towards massive bodies. That is what GR says. That is what Newton said. That is what Kepler, that is what Tycho Brahe, that is what the data says. That is what That is what Maxwell said. That is what quantum field theory says. That everything says that there is this fluid that fills the universe. Everything in modern physics yells there is ether in the universe. The universe is ether. And the universe, what we call the universe, is embedded in the ether. That is what GR says to me. You might as well say that you appreciate the Earth-centric model more than the Sun-centric. You like the Earth-centric model. What?
Yeah.
That is what to me, that is how it feels. Like you are for no reason rejecting the ether, the gravitational ether, the general ether interpretation of modern physics. Because you still need to explain the quantum field.
Okay, can you send me some papers about this ether model and so on? Because I've never heard about these.
I couldn't hear anything you just said. You want me to send you papers?
Yeah.
Okay. So the first paper, I'll share with you. I'm in the middle of writing it. Is it okay if I send you a paper that I'm writing? Can you hear me?
Yeah.
Okay. So here is a link to my first paper and the most important one. This is proof of Einstein's special relativity's second postulate. I prove why the speed of light is constant. So that's the most important paper.
Okay, 1 minute.
Here's a second paper about the gravitational ether. Here is the third paper about measuring the ether speed properly and why Michelson and Morley failed.
Yeah, okay, I'll read these.
I mean, the first one is pretty much mostly done. The second one, just a little bit. The third one, very little. So, I mean, if you want, I would love to talk to you as I'm writing it, because then I would be able to explain to you as I'm writing it. That would be the best thing. Are you looking at the papers?
Are you an actual slave, though?
What?
Are you an actual slave, though?
Yeah.
Was that yeah or no?
Yes, I am.
Oh, who's your master?
I'm looking for a mistress as we speak.
A mistress.
Yes. The job is vacant.
You could just not be a slave if you have no master. You could just be free.
That's not good for me.
Why is it not good for you?
I'm kidding. That's just something that my previous mistress used to say every time I said that maybe I'm not gonna come do her laundry. She used to say, "That's not good for you to be free. You need to not be free."
Did you escape?
Never. I never escaped. No, I enjoy being a slave.
So why aren't you a slave anymore?
Because I'm traveling, so as a traveling slave, it's difficult to find a mistress.
But why did your old mistress let you travel?
I actually set her up with a guy, so and then I had to leave the country. And anyway, long story. I'd rather actually not discuss the details because it's not just me, it's also other people, so it's not so good. Anyway, what do you so are you leaving now, or can you keep talking? What?
Maybe I will leave soon.
You leave soon?
Yeah.
Look,
but remember,
Hmm.
apples don't fall down, the ground falls up.
Yeah, I used to teach this. Whatever you say, I used to repeat this nonsense. I used to, yes. I used to belong to that cult. You don't have to. I mean,
The
there's
ground falls up cult.
What?
The ground falls up cult.
Yes. So I used to believe that nonsense. I don't believe it anymore. I mean, it's just a. I mean, it's a crazy interpretation. You can live and make, as we can see, you can make fantastic predictions with such a terrible misinterpretation. That's fine. The math always saves you. It's fine. But you can have a much, much, much simpler, more intuitive understanding of GR, SR, and QFT. And everything fits together so harmoniously with black holes, and you can go into a black hole so easily. You can understand so many more phenomena so easily. Everything becomes so simple. Once you understand, certain things, I agree. I don't understand either, but I don't build Nobel Prizes on top of not understanding something. Once I don't understand something, I stop. That's it. That's the end of that discussion. I don't build thought experiments based on not understanding spin. That doesn't make that's ludicrous. Who does that? I admit I don't understand what spin is. Now that I don't understand what spin is, let's build on top of not understanding and let's prove that reality is not real. Oh, wonderful. Yeah. I feel like I'm talking to myself. Like I talk and you're not responsive. Is there any reason why you're not responding?
Oh, I was away.
Jesus. Why do you do that? Why can't you have like a normal conversation, like a back and forth?
I'm gonna go eat food.
Okay. I'll see you later.
Bye.
Bye. Jesus Christ. You know, I need to ask him. Can you send me more people like you my way? I need to debate this much more. Do you know of a server where these things are discussed? You need to watch today's video. I was actually debating one of them. One of them. Mm-hmm. 1 second. Any messages? Mm-hmm. I need my bank account. Let me send my bank account. Mm-hmm. 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 What's going on here? Mm-hmm. Mm-hmm. 1 second. So I told someone, I told a girl that I never cheat. So she says, people who cheat say I never cheat. That's actually the liar's paradox. Let me send her a link. I was just watching it yesterday, the liar's paradox. The liar's paradox. The liar's paradox. All right, let's hear it.
It's very simple and very old. It goes back at least to the year 2265. You say you are lying, but if everything you say is a lie, then you are. Okay, the liar paradox in the real world goes back at least to
Okay, I need to get my account details. 1 second. Mm-hmm. What is going on? Mm-hmm. Okay, I need to get a text message. There you go. Mm-hmm. Mm-hmm. How can I get the details? Like, I want to ask someone for money. What is, like, what do they need to know? Where is my account details? No, that's not it. Hmm. Can I copy paste? No. So I need to copy by hand? This is so ridiculous. How can I get my account number? I just want to get the number. Oh my god, I have to write it manually. Okay. Terrible. Okay, so there it is. I can actually tell everyone my account number, because then you can send me money. I don't know the address. What's the address of the bank? I don't know. Let me give him the name. Okay. All right. Okay, we're done with that. That was a very interesting discussion, to say the least. It's so difficult to find people to debate with. Oh, I didn't send the last message. This is very interesting that he wants to read the papers. He asked me for papers on the topic. We need to write these papers ASAP. Oh, Let's see what's going on with who just. Oh, 1 second. This should be somewhere here. Mm-hmm. One second, let me just thumb up everything. Okay. Oh, I have a message on. Mm. You are allowed to do anything you want. You are privileged. Privileged. I have to do everything you tell me because you are my owner. She says, no, I'm not white. But you are not a colonizer, but you're a beautiful young woman. So everyone wants to make you happy. Okay, so let me just check this. Okay. Okay. It's getting late. I'm gonna have to leave soon. Let's close this. Okay. So close this window. So calculator. One second. What about um okay. Mm-hmm. 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 Yeah, maybe I should spend some time writing these papers, because if people are going to start asking me for papers and I don't have papers, that would be very sad. Mm-hmm. Okay. Mention. One second. Mm-hmm. Okay. Okay, so given postulate, the velocity of the water surface waves is a constant. If an imaginary person I don't know. What should we call it? These are like caveats. What just happened? Oh, am I viewing? Oh, let's go into editing. This is maybe caveat. So, given postulate, what do you mean given postulate? I mean, it is a postulate. The velocity of the water surface waves is a constant. If an imaginary person is stationary relative to the water, and they measure the velocity of the water, then they will measure it to be a constant. Okay. Given all waves in this discussion are water surface waves. Given the rubber ducky is blind, it has no eyes, it cannot see anything, it can only detect waves with its 2 wave detectors. Given the rubber ducky is a good scientist, therefore the rubber ducky does not know what time is except via time scientific definition, namely by its measuring apparatus and its metric, tick and tock. Given this experiment is done in complete darkness, there are no optical sensors detectors in this thought experiment / paper. Naming convention. The rubber ducky has 2 detectors. One is the tick detector at the bottom, and 2, the tock detector is at the top. Notice. These are good notes. This is what happened. This is what happened when I was actually talking to someone as I was writing it. Notice. There is no rate of tick-tocking. Rather, the tick-tocking is the rate. Or one could say that to the rubber ducky, it appears that the clock is tick-tocking at a constant rate, regardless of the rubber ducky's velocity through the water. Notice that the rubber ducky does not exist. Rather, only its clock exists. That's not clear. It's not rather, it's except for. Except for. Notice that the rubber ducky does not have any other parts except for its clock. Notice that we can make our clock more complex, such as add a horizontal clock. However, this will not change the measured speed of the waves, because the definition of speed is distance over ticks. The distance never changes as the rubber ducky does not stretch, and the tick never changes as the metric of time. Conclusion, that's it. That's it. Mm-hmm. Okay, we'll come back to this paper. You know what I want to do? I want to remove all what do you call it? Styles. Everything should be normal text. Except for bold. This is the abstract. That's it. And these are the figures. Caveats. Wait, so what do the sections look like? I need to be consistent. So abstract has colon? Is it bold? No. Now it is. Okay. So that's the abstract. I see introduction. So colon. So I don't need the colon. Everyone knows. Okay, abstract, introduction. Caveats, conclusion. References. Is there any other reference? I don't want to mention the ether. Okay. So in this paper, there's no ether. Okay, the next paper is gravitation ether, an ether flux theory to explain gravity. Gravitation ether is just an interpretation of GR. An ether flux, it's not a theory, interpretation of general relativity. It's just an interpretation. An ether flux, interpretation of general relativity to explain gravity. Why does an apple fall from the tree and accelerate towards the ground? Why does the moon orbit the earth? In this paper, we will propose a new interpretation of GR to explain gravity. We will posit that the universe is completely filled with an incompressible fluid. This fluid must flow I think we named it later. This fluid must flow into massive bodies. No, what do you mean must flow? Flows into well, it just annihilates. It doesn't flow into it. This fluid annihilates this fluid annihilates upon contact with massive bodies. So first say that the universe is filled with this fluid, but there is a positive pressure. We posit that the universe is completely filled with an incompressible fluid. This fluid is in general, it's under pressure, is pressurized by fluid creation, by constant fluid, constant homogeneous. It's isotropic. It's a constant fluid creation everywhere, aka dark energy. This fluid is pressurized by constant fluid creation. So there's always new fluid being created that creates the positive pressure. This fluid annihilates dark energy. This fluid annihilates upon contact with massive bodies. Creating low fluid pressure. So there's low fluid pressure. So a pressure gradient So a pressure gradient is therefore formed around all massive bodies. Well, if we keep calling it fluid, it's okay to call it fluid, causing the fluid to flow into all massive bodies. As this fluid flows into massive bodies, it drags everything in its path. Things like apples and moons get dragged towards massive bodies like the Earth. But also things like light that wave through the fluid get dragged in. This is the only explanation for gravity. No, it's not. This is a simpler explanation for gravity. So compared to the common curvature of space-time. This is a simpler explanation for gravity. It's not an explanation, it's a simpler interpretation. Interpretation. She doesn't. She says she's basic looking. You need to treat me. She says it's lust. Everything I'm offering her is lust. Men confuse lust for love. Oh my god, I need to leave. Oh, I need to really leave. All right, okay, we wrote a little bit. We debated a little bit. We did a little bit of everything. We worked on some papers. It's good. All right, we're done. We're done.